Well, hi everyone. Thanks a lot for being here, and welcome to this session, Easy Microservices with JHipster. Let's first introduce ourselves. So I'm Julien Dubois. You can follow me on Twitter at Julien Dubois. I'm the JHipster creator and still lead developer after 4 years. I'm still not fed up with it. And I'm the Chief Technology Officer at Ippon, so I've got some advertisement here. And my co-speaker.
So my name is Deepu K Sasidharan. I'm the co-lead of JHipster. I work for a company called Xebialabs. We do a lot of DevOps, enterprise DevOps products. We are based in Netherlands. I also live in Netherlands. So nice being here. This is our second talk.
Yes, second time.
Last year we did the same on November 4th, I guess. Yeah, I think in the same room. Yeah. That's nice. Okay.
Yes, we meet every year for Devoxx.
Yeah. And I'm also currently writing a book on JHipster. It's available from Pact. I'll put up a special, they give some special discount code for the book. If somebody is interested, I'll put it up after the session. So you can grab a copy if you're interested.
It should be a good book. I'm reviewing it.
Yeah.
So what are we going to do for the next 3 hours? We'll see how to create microservices quickly and efficiently, of course, with JHipster. We will talk about architecture and design, about scalability, failover, best practices, and bad practices also. I should have said it also. And about microservices in production and, let's say, in real life. We will quickly see that with JHipster you can do simple microservices very quickly. But, of course, our idea is to work for real-life applications, which are much more complex than the basic hello world that we often see in conferences. So here we're going to have something hopefully much more complex and complete than what we usually see. So we're going to do it with JHipster. Well, first of all, because we love JHipster.
Of course we do.
But why would you like to use it also? So first of all, today we are clearly the most popular application generator in the Java world. We've got nearly 8,500 GitHub stars, which is very big for a Java project. We've got nearly 400 contributors, so nearly 1 million installations. So it's a bit hard to count, but a lot of people are using it, clearly. We've got more than 200 companies which are listed on our page. We just won 2 awards. The first one is the Duke's Choice Award from Oracle, and the second is Jack's Innovation Award at Jack's London, I think.
Yeah, Jack's London.
So we just won both of them this year, which is quite unique, I think. By the way, we just met Stefan Johnson, who is doing Devoxx, and he told us he was using JHipster on a daily basis for Devoxx. So if you just use the Devoxx website, it looks like you use JHipster quite a lot. Second thing is that JHipster is fully open source. We don't have a enterprise version where we try to make you pay some stuff. It's totally open source and community driven, and that's very important for us and hopefully for you also. It is based on the most popular frameworks today. So for the backend, we are based on Spring Boot, and for the frontend, we are based on Angular and soon React. There will be a talk on Thursday with Matt Rabel and Deepu on React versus Angular. So both are great, of course, and with JHipster, you will have the choice. So we are not taking sides with JHipster, but we give you the choice to use the best tool you want. And for microservices, so we make heavily use of the Netflix open source libraries. We will see there are lots of options, and it's more complex than that, but to put it simply, I mean, for our first slide, we use Netflix.
There was a PhD paper which estimated that you can do 2,600 options with JHipster.
26,000.
Yeah, sorry, 26,000 options with JHipster.
Yes, and so yes, it's a PhD paper that will go pretty soon. Still secret. We can talk about
like that.
And I think that there are more options today than when it started because it did it 1 year ago. So we removed some options, but we also added quite a lot more. So it's quite big. So we talked a little bit for 4 minutes, but with JHipster we've always been very hands-on and focused on the code. So as Linus says, talk is cheap, show me the code. So let's code a little bit. So the first thing, we'll do a simple microservice. I said as simple as possible because you've got no database. We'll see it's not that simple. But It's one of the simple things you can do with JHipster. So we will see different ways to generate applications with JHipster. I'm going to start with the first one. We will, on purpose, change the ways to generate just to show you different ways to do it. So I'm going to JHipster Online, so it's hosted at start.jhipster.tech. It's also all free, like everything we do. By the way, we need to thank Google because they gave us $5,000 of credits to host this for free. So it's not really free. It's free because people give us free credits. So you need to create an account. I already got one, of course. And so this tool is basically to help you generate your application with a web page instead of using a command line, which we'll do later. I'm doing it now because it's easier like that. So it's going to ask me what kind of application you would like to create. I'm going to do a microservice. I'm going to call it microservice. I'm going to keep the default options for security. Only we said it was going to be very simple, so no database, no internationalization, nothing complex, the first one. I'm going to generate it on GitHub. So I just pushed a few buttons. It's generating me the app. I can go there. So my app is already generated here. I've got full documentation for everything. And I'm going to clone it. Clone it like this. Shady workspace, Devoxx, git clone. And I can already run my app with Maven. So JHipster generates a full application for us, including a Maven wrapper. So Maven is already included in it. So I just need to run the Maven wrapper, and everything is running. We'll have a few stack traces. This is normal. We'll quickly see why we have this. And my app is already running, so it was on port 81. So my app is here, and I already got my simple microservice running. We've got a simple web page. We have some documentation here to help us. And if we want to have a look at the API, just click here, and we've got some basic Swagger definition of our application. It's pretty small because we didn't select anything, so it's pretty small for the moment. That's the first simple microservice. So as we saw, I didn't code anything. I just clicked a little bit, and I've got a full Spring Boot microservice with Swagger, with some service discovery stuff, and so on working. And I didn't do anything. So that's what I said. The first one is going to be very easy. There's one more thing we need to talk about. When we started, you saw we had an error message. So the error message is on purpose, of course. As I'm in development, JHipster is trying to start the application, whatever happens, but it's not totally good. What it's trying to reach is something called the JHipster Registry. There are many ways to run it. I'm going to run it with Maven, but there are other ways to do it. So the JHipster Registry is three times. It's three different things. Let's just have a look. It is a Spring Boot config server, so it's going to configure my microservices. It is doing service discovery using Eureka, so it's also a service discovery server. It's also a management server. It's giving you lots of monitoring and management screens on your application. So now I have started it. Let's run my app again. And if I go, so I will not have any stack traces anymore. And if I go to the JHipster registry, I need to log in because it's secured, of course. And I'm going to have my app available in Eureka. It didn't start yet. Should start pretty quickly. Here it is. So my app is already registered into Eureka. It is configured using Spring Boot config. So this is a Spring Boot config server sending configuration to the microservice. Well, there are lots of options here. You can also do encryption and so on. I'm not going to go into the details for the first demo. And the third thing it does is monitoring and administration screens. So I can go and see the metrics of my application. I can see we've got some REST endpoints, not a lot because it's the beginning. We can see the Spring Boot configuration. We can see the logs of the application. Oh, shouldn't have clicked here, in fact. And, oh, sorry, went too quickly. Oh, hello. So here we see the logs of the application. So I don't need to go into, I don't know, any specific tool to have a look at the logs of my application. And if I want to change log levels, well, there's also here a logger screen where I can just click. And I will be able to change the logging level of, I don't know what, Spring Security. If I, security. Now I want Spring Security in info mode. It's going to be in info mode. So I can change the log level at runtime and see the logs at runtime also. Last but not least, I can see the Swagger API we just saw, but here we've got Swagger UI, so it's much better to see it here with a graphical interface than doing what I just did before, clicking here and seeing it like that in JSON format. So we just saw the JHipster Registry does three things: string include config, service discovery, and management server. Now we're going to work a little bit on our app because we saw it was a very, very simple app. Of course, we want to do something useful with it. As it's the first sample, we're doing like everybody an hello world. So let me just make it a little bit bigger. Devoxx. So I'm going to type JHipster. So it's a command line that is installed with JHipster. And I'm going to use what we call a sub-generator. It's something that is going to improve my application. So the first one, we call it Spring Controller. So it's going to add a simple Spring MVC controller and a test. So I'm going to call it hello. I'm going to say it's going to have an action called hello. It's a get, and that's good. So it just generated a very simple app for me. If I compile it, it's going to, well, recompile my app. And as we can see above, my app will restart automatically very quickly. And I can come back here and have a look. Oh, and have an error. No, it just, oh, sorry, failed to start. Oh, sorry, it's using the same port as the registry. I did a mistake. Here, port conflict. It happens. I'm going to open it in IntelliJ and change the port. Didn't try. Or, let's do it like this. Just to show, also my application is automatically configured. I can just open it into IntelliJ. IntelliJ recognizes my application as a Maven project. So I've got Maven working. Well, basically, it recognizes everything. So I just need to go to my Spring Boot configuration and say that the port is not 8081, it's, where is it? Yeah, it's 82. And just to show another way to run the app, I can also run it directly here in IntelliJ. IntelliJ recognizes my app as a Spring Boot application, so it's just automatically configured. I just need to start it. It's going to run. This time without any port conflict. And if I come back to my app here, so the microservice is up again. And this time, if I go to the API, I can see my microservice running. And I've got the hello world being here. I can click on it. And I'll try it out. We said give us hello because that's what we want. If I want to, because we went, we had a little stop in the, let's say in the show. If I go to have a look at my microservice, instead of saying return hello, I would say return hello world. I just click on compile, and this time it's going to restart everything automatically. So now when I do try it out, it says hello world. So everything updates automatically. Let's not talk about security because I lost some time. And let's move on. Yeah, sorry. Just one thing. Of course, everything is fully secured. I chose JWT.
Yeah.
We'll talk about it later. But everything is fully secured. So what did we see? So we created a very, very simple Spring Boot microservice, just a few clicks. We saw the JHipster Registry, which helps me to monitor my app, configure it, and scale it. That's what we'll see later. And we saw we could improve it using a subgenerator, by just adding a simple Spring MVC REST controller. We'll, of course, do something much more complex afterwards. So the first really quick demo was about doing a simple microservice. Now let's talk about microservices architectures and see how we're going to do some more complex stuff in the real world. I'm going to hand it to Deepu.
So before we start, probably some of you would already know this, but for others, let's take a quick look at the popular microservice patterns that are commonly used. So there is a pattern called aggregator pattern, and there is a variation of it which is called proxy pattern. Then there is chained, then there is branch pattern, shared data pattern, and asynchronous messaging pattern. And some of it are very self-explanatory, like the asynchronous message pattern, which means everything is done using message queues and Kafka and stuff like that. So we are not going to see in detail about the last four. Let us take a look at the first two. That's because these are the patterns that we use in JHipster. So in terms of aggregator and proxy pattern, so these are the most commonly used patterns, and it's made very famous by Netflix because they use aggregator proxy pattern themselves. It's also known as the iceberg pattern because when you go to the API, you don't see much. You just see one service. But underneath, there could be thousands of services which does the stuff, but you only see one gateway service. So typical characteristics are that you have a gateway or API gateway, and which take care of routing your request to various underlying services, doing aggregations of what is returned by the underlying services and stuff like that. So gateway can act either as an aggregator or as a proxy or as both. In JHipster, we normally use the gateway as a proxy more of. We don't do much aggregation because aggregations normally are domain and business specific. It's very difficult to generate that. So it's up to you if you want to aggregate few services to do something. So otherwise, we by default use it for proxy.
Oh, so the basic idea, we will have more of the slides afterwards. It's going to be more and more complex. But the basic idea with JHipster is that we have a gateway in front of our microservice architecture. It opens up the door to one or several microservices. Well, probably several. Otherwise, you should do a monolith. Everything is wired up using the JHipster registry that we just saw. You can replace it. We will show other options afterwards, but that's the basic idea. And everything is monitored with something we call the JHipster console, which is basically the Elastic Stack with some customized dashboard that knows what you want to monitor. So this is very simple to generate. That's what we will do several times today. It is already very powerful because the gateway has got a lot of security,
Rate limiting.
Rate limiting options, and it can generate also front ends from your microservice backends. JHipster is all about generating stuff. Instead of generating everything inside the same application, what we do with monoliths, here we generate one part of the application on one microservice. Well, we generate the backend there, and we generate the front end on the gateway. And you can mix and match stuff depending on your needs.
So in terms of the client side, actually the gateway is kind of an aggregator. So it aggregates the client side for
yes. Yeah. Oh, yes.
So, yeah.
Yes. Exactly. You can already do aggregation just on the front end. In that idea, your Angular or your React application is a real application that does aggregation. And of course, if you want to do more complex stuff, you can also do aggregation with microservices, and then those would be done in Java. But it's, let's say, more advanced patterns. And for the beginning, we are with the simple ones.
Yeah. So before we delve further into this, there is always a war between microservices and monolith, and whether to do microservice or to monolith, and there are people on both sides. We are not going to take any sides. So from our experience doing microservices and developing the microservice part of JHipster, it's been more than a year now since we started the...
Yeah, maybe 2 years now.
Yeah, almost 2 years, since we started the microservice support and stuff. So some of the good reasons for choosing microservices are we have listed them down. If your application scope is very large and not well defined, that means you don't know what you're going to end up with. So you start with an idea, you know that it is going to be huge, it's going to grow, and you're sure that it's going to be, you're going to keep on adding features and stuff. Then it might be worth itself to start as a microservice. Another option is, good reason is, when you have a huge team, it's very difficult to build monoliths with a huge team. Mm-hmm. You keep working on the same stuff, then microservices are good for you. There might be some duplication of work, but still your teams will move faster. Another thing to consider is, when your average skill set of your team should be good if you are choosing microservices, because microservices are not so simple. It's much more complex than doing monoliths. So you should have a good team composition to do that. When time to market is not critical, because you might think that it is very easy to build microservices and go to production. But compared to monolith, it takes more time to get everything right, set up your infra and stuff like that. So time to market should be a factor as well. You should be ready to spend more on infrastructure, monitoring. With monolith, you may not be spending that much on monitoring infra and stuff like that, but with microservice, since a lot of moving parts, those are very important. And when your user base is huge and you know that you would want to aggressively scale, then microservice is also a good fit in those kind of situations, like Netflix, for example. Some bad reasons for choosing microservices, which we see that some people do, because many people choose microservice because they thought it was very cool. They didn't know the implications. So you wanted to impress your boss or someone so that you could do microservices. Yeah.
It doesn't impress girls.
Yeah, it doesn't. It doesn't. Peer pressure, of course. Everybody is doing microservice, so you have to do microservices as well. And you thought that microservices may perform better than monolith. Sometimes true, sometimes not so true. So it depends on your use case and other factors we listed. And you always have to keep in mind, you're not Netflix, Google, or Facebook. So most of the times you might not need microservices. Monolith might be sufficient for a use case. So always have to carefully choose between the two. And of course, if your use case demands, then microservices are very good for you. But choose wisely.
Just wanted to say just one thing, just as an example, the JHipster online application I just used. So this is a monolith.
Yes.
And so I'm myself doing monoliths.
Yes.
If I can, because I could do that in a couple of days using JHipster. I could host it for very cheap. It costs $30 per month, something like that. Yeah. So if you have a simple need like I have here, you are alone, well, don't use microservices.
The same can be built as a microservice as well.
I could have.
Of course, you'll be paying more for.
But it would have cost me a lot more money.
Yeah, and some more days to.
Yeah, more problems, more issues. Sorry.
Okay, so let's take a look at service discovery. So normally, service discovery helps your gateways to identify services or endpoints. So you don't have to manually keep track of your microservices. So they are discovered automatically. Service discovery normally will also have load balancers to regulate traffic to your services, so that when you have multiple microservices serving the same stuff, and when you make a request, it is load balanced properly. We'll have some demos of that later. Yes. Based on location, load balancing can be done in two different ways. So there is a client-side discovery pattern. Example is Netflix ribbon. So in this kind of pattern, the client is responsible for discovery and load balancing. The server just keeps track of your services. It just acts as a registry. Then there is a server-side discovery pattern. An example is Amazon's Elastic Load Balancer. So where you have a dedicated server which is responsible for discovery of your microservices and also for the load balancing. So in both these scenarios, they need a service registry for you to discover the services itself. And with JHipster, we use Netflix Eureka for service discovery. So it's kind of a server-side discovery pattern. And for load balancing, we use Netflix ribbon. So it supports a lot of cool options like fault tolerance, supports multiple protocols, asynchronous, it supports asynchronous model or reactive, which is a cool phrase nowadays. So it supports caching and batching of requests and a lot of other cool features as well. So this is by default what we use for load balancing ourselves in JHipster. Then there is circuit breaking. So these are all very common concepts in microservices. So these are stuff that we need to understand before we delve into microservices, because these will be the terms you hear all the time. So circuit breaking in JHipster, we use Netflix history, and as we said, like we use a lot of Netflix libraries, and these are very good for this job. So main features of Hystrix is that, main features of a circuit breaking system is that it should stop cascading failures, and it should support fallback and stuff, and Hystrix is very good at that. So it definitely supports stopping cascading failures. It supports fallback and graceful degradations. It supports fail fast and rapid recovery, which is very important when you're doing microservices, because you need to know that when stuff is failing, you need to know fast so that you can recover. It has real-time monitoring. It has even a dashboard for that, which is cool. It can also monitor configuration changes. It supports concurrency. It supports caching, request caching. It can work with caching mechanisms to cache your requests at one layer instead of taxing your actual services for that. So they are a bit more complex topics. It also supports automated batching and request collapsing. That is, like, if you have so many requests for the same stuff, it can be batched, and there is also request collapsing feature with it. Those are the cool keywords in microservices. We also want to highlight that with JHipster, we closely follow 12 factors of web app and SaaS development, as you can see. So I'm not going to go into details of what each of these are. They are very self-explanatory. One code-based tracked in version control. Yes, we always evangelize that. We even do automatic commits and stuff into Git now with our recent version.
Just reading the 11th, treat logs as event streams. We just saw the logs in the JHipster registry, so you can imagine it works quite well.
So we kind of try to follow this as closely as possible.
And by the way, we're starting doing that before Spring Boot existed, so it's already something we were following. And Spring Boot also follows the 12 factor very closely. So we're all doing the same
work
thing
hand
together.
in hand.
Yes. So I'm going to go a little more in details about what is included into JHipster, because here we had like a theoretical view of what you could do with microservices. Now let's go into the details of what is done with JHipster, and then we will, of course, do a demo.
Off with the boring part, and let's start the fun part.
Yes. And so the gateway, well, people call it an edge service, a gateway. This is basically the entry point to the application. It acts as a proxy, so it's going to do several things, basically to our microservices architecture. The first thing is that it protects the microservices. It can do some rate limiting, for example. It routes the request, so when you scale your microservices, it's going to know which server is up, which server is down, and it's going to route and load balance the request accordingly. And it's also going to serve the front end. We talked about Angular and React. Well, here the gateway is also responsible for serving the front end. As usually, people have a look at this slide, which we have everywhere on our website. People think by default you only have one gateway. Well, it's basically wrong. Most of the time, people have several gateways. On one project I'm working for, because that's what my idea here. We've got one for the clients, the end users. There's one for the internal back office, and there's one for a specific mobile app, for also some specific kind of end users. So it's quite common to have several gateways for, let's say, developer, to have a better developer experience. I mean, you have, when you do the mobile app, you just have the API that you need, but also for security. For the back office, they have access to invoices. You don't want people in the mobile app to have access to the invoices from other people. So maybe it doesn't have the same security rules, or maybe also it doesn't have the same rate limiting abilities. Maybe you want to have some clients who are more important than others. Typically in that use case, the client-facing app is far more important than the mobile app. So if there's an issue, we just kill the mobile app.
Yes. And I can imagine that it's much more easier to do stuff in separate gateways, so you don't have to do everything in a single gateway, which becomes much more complex.
Which becomes huge. It's also better for the team, of course.
Yes.
Because you can, that's also the same idea for microservices. You can separate teams much more easily. So if you got huge teams, it's of course one of the biggest advantages of microservices. On another project I work on, we've got 30 developers. So you can imagine if we were all building a monolith, we would not. What do we say? It's like what one developer can do in 1 month, 2 developers can do in 2 months. It doesn't scale, basically. So yes, that's one of the good solution to scale when you get a big team. And yes, having several gateways is sometimes called the backend from front-end pattern. You do a specific backend for your front-end. So it has been, let's say, theoretically discussed here by, I think it's Martin Fowler from ThoughtWorks. My previous slide was on, let's say, a normal gateway, but sometimes gateway get more advanced than that, and they go into the API management world. So a gateway like we have in JHipster can either be itself an API management solution or work with another API management solution. What do API management solutions do? Usually they do 3 things. They do quality of service, so rate limiting typically. They do security with OpenID Connect, GWT, that kind of security solutions. And also they usually give you a developer portal with automatic documentation with Swagger. We already saw we had it, so you already know that we do it. So you can either have it for free with JHipster, and it works very well. And we've got, I don't know, hundreds or thousands of companies doing that. Or you can plug an API management solution on top of JHipster that does it. I've got, I don't know, 2 or 3 customers doing it, and they pay for it. So if you want to pay, you can pay. But it's supposed to be better. Anyway, API management is something that is becoming more and more important because as the number of microservices grow, of course, all of this is going to be more and more important. If I come back here to my Swagger documentation, you can imagine here that if I have 10 microservices that are listed here and I can test everything, it's a lot more easier for me as a developer to use that than I don't know,
then use
doing
Postman
it
or something and like they do everything manually. So.
By the way, there's a cool project called the Swagger CodeGen that can generate a Swagger clients from a Swagger definition.
We have first-class support for that as well.
We have of course. It's one of the options that I didn't click, but we have first-class support for that, and also because the guy doing it, Christophe Bornet, is the same person doing the Java support for Swagger CodeGen and is a core developer of JHipster. So of course we have first-class support. It's the same person doing it. Configuration management, as we saw also with JHipster Registry, well, Spring Boot can be configured in many different ways.
Officially, there are 13 ways to configure it.
30? I didn't know that.
Yeah.
Officially? Yes.
On the website, there are 13 listed ways to configure Spring Boot.
It's anyway, it's just well, very complex to configure, and well, very complex. No, it's very easy, but you get lots of options, so you got to choose wisely your options. That's the first thing. And the second thing is that you probably want to have a centralized configuration. If I come back here to my registry, we've got a very basic configuration, but we can see that the main thing we configured is saying so we're using GWT authentication, and we've got a shared secret key, which by default is called my secret token to change in production. So you can imagine you need to change it. Don't do like Equifax and get it. And what is interesting here is you have a shared secret. If you put it into every app, well, that's probably a security issue. First of all, you should not put it into the Git repository of each application. And if you copy-paste it everywhere, well, you can be sure that at some point you will have an issue. Here, the idea is that our security, our Spring Boot configuration server is going to send the same token to everyone. So each microservice is automatically configured correctly. And if you scale them up, they will, of course, get the right configuration. So it's a very important way, important solution if you want to scale your microservices. So configuration management is very important. If you use the Spring Boot config with JHipster, so all microservices will be automatically configured, of course. They can be stored into Git. Not everybody does it. There are some other options, but by default, this is what we do. So you would have a specific Git repository, which would be secured, of course. And as it's Git, what is interesting is that you can tag and roll back your configurations, which is very nice. And as we just saw, the JHipster Registry adds a nice UI layer on top of it. So that's well, easier for you than using Spring Boot config by default. You can see it in YAML, in JSON, as a table. And if you've got some secured token in it, you can we have a little screen to help you encrypt and decrypt stuff using your key. We've got documentation here to help you. By default, of course, you have the encryption key to configure. So
yeah, enough of the talk already, I guess.
Yeah.
So let's start with the microservices. Let's start building actual microservices. So for this demo, what we'll use is we'll use the microservice generated earlier from the JHipster online web application. We'll use the same, and we'll add on more microservices, gateways, and stuff to make it an entire architecture. So our second microservice will be a bit more complex. The first one was very simple. It didn't have a database or anything, just had a simple controller. The second one will have a MySQL database. It will have a second level Hibernate cache. It will have several entities, which we will generate using our own JDL studio, which we'll see about in some time. So the JDL is available on this link, which we'll open it in a way.
Afterwards.
Yeah, of course. So on the gateway, we'll also generate these entities, and we'll show you how these interact together. So yeah. Let's start with generating the first one.
So Deepu is going to talk, and I'm going to code.
We'll do the coding.
So I'm going to remove the slides and put them back when we can.
Yes.
So
the first one we'll use. We already saw how to generate the application from the web application. Now let's see how we can do it from the CLI as well.
Yeah. Let's do it here.
Yeah. So this will be our second microservice.
Yeah. So I'm going to my Devoxx repository. I've got already my first microservices. Let's create another one. We'll call the shop, online shop. Online shop. And this time I'm calling the CLI.
Yeah.
It's going to basically ask me the same questions that we had with the web application, but this time I need to use the command line. So I'm selecting also microservice application. We get a name. This time I'm not doing a bot conflict. I'm using JHipster Registry. I'm using JWT. Yeah. This time I'm taking a database. I will use MySQL. Okay. So by default, we have a distributed cache, which is called Hazelcast. This is only the default with JHipster for microservices, because we know you will want to scale your microservices. We'll talk more about this later. Maven, and all the rest by default. So this is generating another microservice.
Yep.
Here it is. It's done. I can already run it. Well, I open it also with IntelliJ. And so let me just, so this is, so this is the registry running.
Yeah, that's the registry.
Okay, and so what I don't have running
is the first microservice.
It's a default microservice, which is here. Okay. This. Can kill this one. Sorry, I'm just trying to have it easily readable. Okay. So my app is here. Let's run it. And, well, let's see it appearing in my JHipster registry. Oh, hang on. We should, it's appearing now, but let's go to the slides.
Yeah. So before that starts up, let's see about what is JDL. So JDL is a JHipster specific domain language. So it's a DSL for generating entities with JDL. So it's a neat way if you're doing an actual application where you will have a lot of entities and relationships, because you can use the CLI, but for once you have more than 2 or 3 entities, it becomes difficult doing everything in the CLI. So we developed JDL for that. So it's a very simple JPA-ish kind of DSL. So you can define your entities, you can define relationships, you can define options for entities like pagination, search option, which microservices belongs to, and all those things in a nice DSL. Then you can import it using JHipster. So we'll see how that importing works in the next step.
Yeah. So we have the 2 microservices running. Well, let's go to the JDL Studio. Yeah.
So to work with JDL, we also developed a web app called JDL Studio. It's like a visual editor where you can do your definition while having a UML like visualization as well. It's helpful.
We're just putting something, I don't know, name, string. And as you can see, it updates automatically on the screen. So I can just type and have it automatically showed on the screen. This is an online application, which is also free. You can also use several UML editor for that.
Yes. We also have JHipster UML, which supports working with UMLs and converting them to entities. We also have IDE plugins for this.
Oh yes, IDE plugin with Eclipse, IntelliJ, and NetBeans, which is probably very cool also, because it's inside your IDE, so you don't have to switch like what I'm going to do. Because here I'm going to download or upload my file, which is a little bit annoying. If it's an IDE plugin, it's directly into your IDE, so you don't have to upload and download.
But if you don't like plugins and if you have less stuff to worry about, then
I don't like to install plugins. It really depends. Like always with JHipster, you've got many choices. This one is the simplest one. That's why
I know some people who really hate plugins.
And lots of people using JHipster also work with Microsoft Visual Studio. I'm not sure there's a plugin for that. So my app, here, let's generate those entities on my application. So my current application, if we go to the JHipster registry, let's have a look at its API. Online shop. So the online shop for the moment has got nothing. Well, just a basic microservice giving you your profile. Sorry, when we say profile, it's your Spring Boot profile. It's going to tell you if it runs in development or production mode.
What is your environment and stuff like that.
It's it's what we use also internally to know if your application is in development, production, or something else. So here's my app. I'm going to just call JHipster, import GDL. And so the code that's here, I'm going to download it. I need to click here. So it's downloaded. Download. Where's my home? Oh. Download. Here it is. So I'm doing import GDL and my file. Oh, by the way, it works also the other way around. If you created lots of entities, you can tell it export GDL and give you your GDL out of your entities. It works both ways. It's bi-directional. So I'm going to import it. I'm going to generate all the entities for me. So as we did before, I'm just compiling my stuff. It restarts here very quickly.
So and this part is done by Spring DevTools, which is very good for developer experience. And we care a lot about developer experience. So,
and if I come here, we have all our microservices running. This time, so we've got much more complex controllers, and we've got relationships, we've got tables, we've got Hazelcast. It's much more complex than what we just have before. So we've got 2 microservices, but what's annoying is that I can't show much of it because we don't have a front end, we don't have a gateway.
Yes. Now we need to generate a registry for that.
Let's do
gateway for that.
Let's do the gateway.
Yes.
Devoxx. No, everybody's used to it. MKD gateway. JHipster. So I already selected. Oh, it's a little bit slow because checking the network, and I guess the network access at Devoxx is not very good. So I did 2 microservice applications. This time I'm doing a gateway, which is called. Oh, hang on. I'm not in the right directory. I need to generate in the direct directory where you are, and I just add a little warning for that. So microservice gateway, which is called gateway. Port 8080, this time we've got nothing on this one. It's also using the JHipster Registry. Of course, you need to select the same options. I selected the JHipster Registry for everywhere, for every application. Here I'm selecting
for security and yes.
Of course, you got to be coherent with consistent.
Otherwise, out of the box, it's not going to work together.
Yeah, of course. We will see the other options in the rest of the session, of course. So let's take everything by default also for the moment. I'm using Angular 4, so we still support Angular JS 1, but it's clearly the end of it. We have, I don't know the latest statistics, but it's like 80% of people are using Angular 4. We're in the process of migrating to Angular 5, which was released last week, I think. And of course, we have React support, which is soon going to be released.
Soon. Very soon.
Very soon.
Yes.
I'm not going to use Sass. Yes, now I've got some specific client-side questions, like do you want to use Sass for doing your style sheets? I'm not going to do internationalization, nothing. So I'm generating everything. This time it's going to take a little bit more time because I'm generating a front end. As you know, Angular is going to use NPM and
download the internet.
So it's not NPM, it's Yarn.
Yarn, but
it's the same thing.
Technically both downloads the internet.
And it's going to download the internet. So depending on the network, it can take between, I would say, 30 seconds with a good connection to
up to
30 days.
30 days, oh, wow.
No, it should be pretty quick, normally. And once it's all downloaded, Angular will also compile everything, will generate a full a JavaScript application from our TypeScript code, and we'll be able to run the gateway. Maybe it's time
for more slides.
So I just went quickly here.
I think that's okay.
Yeah,
so
that's
we
okay.
Were here. Yeah, that's okay.
Yeah, we did
so we already saw the JDL studio, so nothing to say there, I guess.
Well, that's what we are doing. So, I said we were going to use start.jhipster.tech. I did it manually, but
it's okay, but it's
the same thing.
So
but what we'll do just afterwards
so we have to generate the entities now.
Oh, so it's yours.
Yes. Yeah, it's okay.
Go.
So we have to generate the entities now for the gateway. So let's see it's still, so we have to wait for that to finish anyway to generate the entities.
Yes, but you're
still downloading the internet. So in the meantime,
what we will do here is we used before the JDL Studio because it was easier. Here we are going to use the command line, so JHipster entity to generate the entities.
Yeah.
It is like we had before. You have a web app which is easier, and you have got a command line which is more complex, more powerful because you can script stuff, more flexible.
Yes.
Depending on what you want to do and what you like, you can choose one or the other. On Pupils, I'm doing both, so you see the best option for you. Here, the JHipster entity is a bit specific because it will understand it's running on a gateway. So it's going to ask me if I want to generate the entity on the gateway itself because it's a real, it's a monolith also. So you could generate your entities here, but it's going to ask me, I see I'm a gateway. Would you like me to generate a front end from a microservice backend, which is elsewhere? So it's going to be the first question to ask me. It's still running, but it's
almost there.
Almost there.
Puppeteer.
Puppeteer. This is going to take forever.
It takes like some time as well. Probably we can start generating in another tab, and by the time we finish, hope this.
Yes, we can be a little bit optimistic. and we can still generate even if it didn't finish. Don't do it at don't do it at home. So what I'm going to do is I'm going to tell it your JHipster entity. I'm going first to generate the product. So I'm generating the product because here you see we've got a product and a category, and this is an enumeration of categories. So I'm going to generate that front end on my gateway. I could do it with the GDL Studio like we just did, but this time I'm doing it on the command line just to show that there are other options. So I'm going first to do the product and then the category. There is no, you don't need to do one before the other. In fact, there is a foreign key between them, of course, but we generate first the entities and then the relationships. Yeah. So you can do
generate in whatever order.
Whatever order you want. So I'm going to tell it JHipster entity product. Do you want to generate that entity from an existing microservice? So as I said, it's saying it's a gateway. So of course I'm going to say yes. Where is it? Well, it's here. It's sorry. I'm going to do it like this, so we don't. The screen is not polluted. Devoxx, online shop. So I want to copy paste because I don't want to do any error now. So here is my microservice. Well, do you want to generate your front end from that microservice? Of course, yes. It's generating it. I can kill it, in fact. And then I want to do the category, which was the other table, well, the other entity we had here. So JHipster entity category is going to ask me the same question. I'm going to tell it yes. We generate. Just take a look if it still hasn't finished. See, oh no, sorry, it's finished. It's finished. Wonderful. You see, just in time. It's,
almost there.
The network is with us. It's taking some time because it's building the whole Angular application. Yeah. By the way, it's doing it for nothing because I'm going to regenerate it right away.
Yes. So
there was an error message, but that's normal because.
And now I think we can let it run the yarn part.
And now it's going to work.
So now it will rebuild the front end again because it's a Angular application in TypeScript, so it has to be transpiled. So.
And I can open it up. I don't know with IntelliJ. Yeah. Oh. If IntelliJ is happy.
On the old.
No, because there's already. Oh, it doesn't want to open a second window. Oh, let's just run it like this. Did it finish? Yes, it's finished. So, close this one. Let's run it. And let's have a look here at Eureka. So here we are going to see our gateway appearing, and that gateway will be connected to the two microservices. So the first one doesn't do anything, so there's not much interest, but the second one will serve the product and the category, so we will be able to use them. So here's the gateway coming.
By the way, we could show the entities generated as well, I guess, in this Swagger. No, for the online shop, I think we already had the entities generated.
Yes.
So it had only profile info. So now
now it has all the
entities. So
and everything is here.
So gateway is here as well.
And if I go to my gateway now, so I've got my Angular 4 front end. I'm going to log in. I've got two entities, the product and the category. So I can create a product, beer, and another product, French fries. And I can do categories, I don't know, food. And I will put my beer and my French fries in the food category. And as we can see here, we've got our gateway, which is just holding an Angular 4 application, which is doing microservices calls through Zulu to a microservice backend. So we've got something quite complete here already. And we haven't started for 1 hour yet.
So let's see what else we had. So Before we go into more complex demos and more details, let's see a short look at what Netflix stack has to offer and what components we use. So we use, as we stated earlier, we use Eureka. So Eureka is Netflix's default solution for service discovery, service registry, and also for service discovery kind of thing. So it can also, it offers a client-server model. So there is a Eureka server which acts as a registry for your services, and it can also load balance between Eureka instances. So it is useful in cloud environments. It was specifically built for AWS by Netflix, so it works very well in cloud environments. There is also Eureka client, which is a Java-based client, which talks to Eureka server. It does service discovery. This is what we use for service discovery in JHipster. It is a middle-tier client-based load balancer, so it load balances your requests as well. So this is also available as part of Spring Cloud Netflix, which is like a Spring's wrapper on top of the Netflix part, which also offers a bit more than that with cloud config servers and stuff like that. So which we also use. Then we have Feign and Ribbon, which are other two important parts from Netflix. So Feign is a Java to HTTP client binder. So it was inspired by Retrofit and JAX-RS2, and of course WebSocket. It has to be. So it is a declarative web service client. So you can also use it like a typical web service client to talk to your microservices as well. Spring Cloud Netflix Feign, which is a wrapper on top of it. It also adds Ribbon, which is convenient. So if you are using Feign alone, it doesn't do everything. But once you use Feign and Ribbon together, then it becomes much more powerful because it also brings in a lot of the options from Ribbon, like load balancing and request caching and all those stuff. So Spring Cloud Netflix Feign is better than using Feign alone because it combines both together, and we use that as well. Then we have Zulu, which is a very important piece of the puzzle as well. So this is used in the gateway for API management and for your request routing and all this stuff. So it's a net service. So it can do dynamic routing, it can do monitoring, resiliency, security, a lot of stuff. We also do, we use it for security, we use it for rate limiting, and you can write more filters for that. So it has a filter mechanism, so you can write filters to do whatever you want with it. So currently, the filters that can be returned for Zul are like, you can write filters for authentication, any kind of security, ACL. You can write filters for insight and monitoring. You can write filters for dynamic routing, stress testing and load shedding, which is like an interesting topic in microservices world. You can slowly increase your amount of requests going to a service, so you can stress test the service until it breaks or something like that. Then you can also do load shedding when some service becomes heavily loaded. You can try to distribute and stuff like that. So you can write filters for that. Static response handling, which is very good if you have say for example Netflix or something, like where you have a lot of static content. Then you don't have to always route those requests to services and load them. You can serve them from your gateway directly because they are static content. You can put them in static content servers and you can serve them. Zul 2 is apparently on the pipeline. It is supposed to be non-blocking and much more better than Zul. It's been on the pipeline for some time now. I hope it will be out soon. Then we can migrate to that. So we use it in our gateway as the default solution. Let's look at API management.
Yeah, I just wanted to add one thing because we've got some time, and there's one thing we didn't talk about. It's WebSockets, because you just talked about it here, and about Zul. There is a limitation with Zul 1. It does not support WebSockets.
Yes.
Zul 2 should support it if one day it goes out.
Yeah, and it is supposed to be non-blocking, so it is reactive and all those cool stuff.
It's supposed to but
HTTP2.
It's not ready yet.
Yeah.
And so for the moment, we support WebSockets only on the gateway. Yeah. And there's a very good support for WebSockets in JHipster, both on the server side and on the client side. There's quite a lot of work here also. And by the way, it's not that bad that Zul does not support WebSockets, because what we would mean here is that you've got your Angular client that does WebSocket to Zul, that does WebSocket to something else. And this is a bit strange to have all those WebSockets routing. What many people do, what I do, is that there is also Kafka support in JHipster. So basically, you've got Kafka between your gateway and your microservices, and Zulu between your gateway and your Angular application. So it's a very good pattern. It works very well. I've been doing that for, I don't know, more than 1 year, clearly. So if Zulu does not support WebSockets, it's not really that bad, in fact. There are better options than WebSockets. So let's talk a little bit about API management. We talked about the JHipster gateway and Zulu, but JHipster goes more than what Zulu does by default. First thing it does, it provides security on top of Spring Boot. So by default, if you use Angular or Spring Boot and so on, you've got security which is implied, but it's not coded for you. Here, what we generate for you is 3 different security mechanisms. So there are more if you do a monolith. You can do session-based authentication. But here, as we're in a microservice world, you can't do session-based. So we're doing 3 other options which are more efficient for microservices. The first one is JSON Web Token, which is what we have done first, which is very, very easily used. The second one is JHipster UAA, which is user authentication authorization. We're going to detail them afterwards. And the third one is OpenID Connect, which is the new Chinese stuff that everybody wants today. We're going to detail each of them. What's important to know with JHipster is that requests are secured by default. That is, when you generate an entity, by default it is secured. It is also monitored. That's why you can see, that's why you can go to metrics and see your metrics, because each method of each Spring Bean is monitored by default. And when you do microservices, the JHipster gateway, it's either sharing a secret, like what we do with JWT, or having a public key mechanism, something like that. What you do usually with JHipster UAA or OpenID Connect. And that's how security is trusted between services. We'll detail that in the next slides. Second thing that you have with the gateway, with the JHipster gateway, is you have rate limiting. When you do API management, one of the most important topic is quality of service. What happens when you have got a rogue user that is doing lots of requests? What happens when your system is too loaded? JHipster provides a rate limiting filter, which is using a library called Bucket4j. It's very important because it uses an algorithm called the token bucket algorithm, which is very efficient for that kind of load. And I've seen many, let's say, competing implementation, including in proprietary software, which is very expensive, and they don't have something as good as this token bucket algorithm.
We used to have a Cassandra-based implementation before this.
Yes, before that.
Much more complex.
Before that, I copied on some other systems, and which are very bad. That's why I know the other systems are bad. And what is good also with Bucket4j is that if you want to distribute your buckets over a cluster, it works with Hazelcast. And one of the other options I didn't check, I don't know if you saw it, is that we support Hazelcast. So basically, out of the box, you have a token bucket algorithm for rate limiting, which can be distributed using Hazelcast for free. And that's very advanced, and I don't think any other competitor has got something like that. And what is good here is if you mix this slide with the previous slide, so the JHipster gateway also handles security. So it's very good. It's very easy when you are in the gateway to do some custom code. Let's say if an admin comes, he's got like infinite requests. If an anonymous user comes, he's got 10 requests.
You can write a more complex rate limiting algorithm.
You can do whatever you want. Yeah. So by default, we have a rate limiting algorithm that allows you, I don't remember how many, like it's 100,000 requests per hour, something like that. I don't even remember. It's a lot. And the idea is that you customize that code depending on your business needs. So of course, this is something we cannot generate because it totally depends on
it's
your
like a
business
reference
needs.
implementation from us.
Yeah. And that's what we usually do in JHipster, is that we generate the technical stuff, and as soon as there is some business stuff, of course, we cannot generate it. Yes. But we give you a template and some good examples so you can then work on your business needs depending, of course, of what you want to do. But you've got a very strong and good basis for what you want to do. A third thing that API management solution do is Swagger aggregation. So as we saw it, the JHipster gateway. Oh, so I saw it on. I showed it on the registry. The gateway does the same thing. The gateway does also.
So you have aggregation going on both your gateway as well as on your registry.
As a registry. Depends on what people want to do. So here I'm on the registry. So it could be good to use Swagger here because you are inside your network and it's secured. You don't want to show that documentation to everyone.
But if you want to show, then registry is not the good place to show that, right?
Maybe you want it on the gateway because you've got lots of developers from outside and you want to give them a nice portal. So maybe that's what you want to do. So we give you both options. Those options are secured. So you need to be an admin by default to see that. And they are disabled when you are in production profile.
So it only works in dev mode, and
here we are in dev mode.
The security is same as whatever security you have chosen. So for this example, we have chosen JWT. So same security applies for these as well. And of course, you can also choose to enable it in production if you want.
Yes.
But by default, we do not enable it in production. There is a switch, like there is a profile which you can use to enable it in production if you want. Because in some use cases, you might want this to be, if you are building API for third-party consumers, then you might want to have this on your production as well, probably with with more security and stuff on more kind of authorization security on top. But you might want it on production as well.
Well, with JHipster, we've got always two profiles. Well, we've got more, but two main profiles: one for development, one for production. That's what we showed last year in this very room. But when you do microservices, it's the same idea. When you are in development, it's everything is done to have something easy for a developer to have a great developer experience. And when you're in production, everything is done so it's very secure. So you are not hacked. So it's different needs. We have a 20-minute break. Do we do it now? Because we're a little bit early. My proposal is that we do the 20-minute break in 10 minutes. Is that fine? Everyone? Yeah? Yeah? Let's do the next few slides, because we're a little bit early and we've got still 3 demos. So we might be happy to have that time later. So we talked a lot about Netflix, but we've got some alternatives to Netflix, because what we just show might not be good for everyone. Do you know why I put Napoleon? Because Deepu did not know, but he is not French. No? Nobody? Well, he's the first consul. Maybe it's only a French stuff, I don't know. Le premier consul. No? I had some fun.
I was wondering why that image was there.
Okay. So that's a question we often have. Some people don't like Eureka. Well, there are some good and bad reasons for that. For me, the good reason to dislike Eureka is that when it has a timeout, well, it needs some time to replicate. Basically, well, by default, I think it's 30 or 60 seconds.
And I think even with that, it's slightly not consistent all the time.
Yeah.
When you kill off your instances or when you start new instances, it takes a slight bit of time for it to recognize and register that.
Also, the issue is that when you kill it, when it starts up again, it takes some time to reconcile everything. So for some time, it's wrong. So when some other services replicate with it, when it's not, when it's just starting up, they're getting some bad data for some time. So Eureka is very stable and very good, and we will play with it. In the last demo, we'll kill stuff and so on. You will see that each time it will come back. It will. I have done that demo tens of times. It never failed. Well, the microservices failed, but the demo didn't fail. But it takes some time. It's not really good. Consul for that is very quick. It's much nicer for that. Then the issue is that Consul, to ensure strong consistency, must be run as a cluster. So one of my clients, a big French bank, they've got a cluster, I think, with 5 Consul that replicate each other, because if you lose that, well, you lose everything. So some people prefer Consul. It's like Angular versus React.
And also, this is a commercially supported solution. So I think if you are an enterprise and who cares a lot about
if you have
support
bank,
and stuff,
it's important.
Yes.
If you have a small startup, you might not want to pay for support. depending on what you want to do. So Consul is very, very popular. It's written in Go. It's open source. Also, what's very good about Consul is that it supports multiple languages. Eureka, it's a REST API, but in fact, the only good client support is Java. There's something for .NET, but, and a small thing also in Go, but it mostly only works in Java. So if you want to have multiple languages, Consul is probably better. And of course, so with JHipster, we've got a first-class support for Consul. So I will show it afterwards.
And we are not paid by Consul to advertise for Consul.
Oh, sorry, because I stole your slide.
Yeah, I noticed it later.
Sorry.
It's okay. So with Consul, the architecture slightly differs. You can see that in the earlier architecture, let me quickly go.
Got tons of slides.
Yeah. Oh, that's way back.
Yeah,
here. So you can see that the blue one, so this is the part which Consul replaces. So it was JHipster Registry with Eureka, Sprint Cloud config, and monitoring dashboards, which was a custom-built monitoring dashboard. And
we're going to replace most of the little boxes, one after each other.
So this is now replaced by Consul. So it doesn't have some of the fancy dashboards that we had in the registry, but it has its own options which we didn't have in the registry as well. So it basically does the work. It does the work of service registry.
It does also, sorry, because this JHipster Registry did service discovery, so Consul does the same thing. It did the Spring Cloud configuration. Yeah. And for Consul, we've got a little hack we will show you that does the same thing. Yeah. So you've got also Spring Cloud
with its own KV store and stuff.
Yes, it's and this is we provide a Docker image for that. I have no idea why, but we have like nearly 200,000 pulls on that Docker image. So what we did,
we did
very, very, very popular, but not sure why. Well, it's very good.
It's basically the same as the original image.
Yeah, but I don't understand why we have so many people downloading that. But and the only thing missing here are the monitoring dashboards. But we'll see afterwards. We've got the JHipster console that does basically the same thing. Not exactly, but
pretty much.
Pretty much. So first thing we changed was the service discovery mechanism. The second thing we can change here is the gateway. With JHipster by default, we use a JHipster gateway with Zulu. Well, we have lots of competitors to that. The main one, one of the main ones is Traffic, which is also written in Go, which is also open source, which is French, so that's really, really good and very important. It's also, you see, it's simple HTTP reverse proxy and load balancer. It does not do API management like JHipster, but it's a very good load balancer and reverse proxy, and it works with Consul very well. That's why the two are links. And you have two patterns with that when you use JHipster. So the first one here, which is, let's say, the most, the one people think about first, that you've got Traffic replacing the JHipster gateway. You still need the JHipster gateway for one thing. It's the static content. The JHipster gateway handles the Angular or React code, so you need it somewhere. So basically, you push it somewhere else. You also need it for security. We'll see after that. Also, security can go out, but just beginning to move some boxes. Yeah.
The main difference here I want to add is that with the JHipster's architecture, since we put all the client side in the gateway for all the microservices, and if you are having client sides for microservices, then you can only go with this pattern because Traffic doesn't have a way to host that client side for you. You need a gateway for that.
Yes, so it can, yes. Yeah. And here Traffic also routes requests directly to the microservices. That's an easy pattern. Probably the most obvious one. And there is a second one. You will see the gateway is going to move. This is basically our first slide, but with Traffic on top of it. The interest here is that you can have several gateways. You might want to use Traffic because it does SSL encryption or for other things. And here, basically, you've got a mix of both worlds. You have the same time Traffic and the gateway, because you want the gateway for the rate limiting, but you want Traffic for SSL encryption and load balancing. Several gateways, maybe. Both options work by default. I'm going to do a small demo.
Probably maybe we can do it after the.
Yes, or I'm going to. My proposal is that I do the demo now, because if the demo fails, then we've got 20 minutes of,
to fix it.
of coffee
to
handle the failure.
Yeah,
it will not fail.
works.
Never fail. No, you never know with the network. Yeah. So I'm going to kill everything because I've got quite a number of things to code. So let's code. Let's code a. Just yeah. Let's code a simple microservice. So okay, here traffic. So the name is ugly. Traffic microservice.
Do you use a special character for that, or
yes,
well,
I copy paste it all the time.
Okay.
This is a specific character. I copy paste it. I'm going to run JHipster. Come on. I'll do the gateway. Yeah.
that one is up.
Yeah. Traffic. Oh. What did I do? Devoxx. The traffic. Gateway. Oh, sorry. I'm tired. Okay. Back to the microservice. So the microservice application, it's called service. It's running on port 8081. Everything is by, not everything is by default. It's using console. It's doing GWT. It's using a database, MySQL. Well, we don't really care because that's not what we want to show. Okay. And here I'm generating the gateway. So JHipster also. So it's a gateway, which is called gateway. By yeah, let's run it by default. It's using console, GWT, everything else by default also. No, nothing. And here for my microservice, I will do like what we just did before. I will do the import GDL. So we've got some tables and some stuff in it. What I'm going to do here on the bottom screen, I'm going to create a new directory called Docker. Because I want to run console and traffic, and those come, well, you can run them like this, but they also come as Docker images, so it's going to be easier for me to run them as a Docker image. So for this, I'm going to use a new JHipster sub-generator, which is called Docker Compose. So I'm just calling JHipster Docker Compose. I'm telling it, oh, and by the way, I need to run Docker. It works better if Docker is running. I'm going to tell it I'm doing a microservice, which is going to use not Zulu this time, but traffic. My different microservices are in the by1 directory. So it's scanning all my directories. It sees the gateway and the two microservices we did before. Those are the two, the traffic gateway, the traffic microservice we just did. So I'm selecting just those ones. I just want an architecture with those two. And oh, by the way, I need to build Docker images of everything. Okay. I don't want to monitor them yet. We'll see that afterwards. So this has generated for me a Docker Compose configuration with console, with traffic, with my gateway, and with my microservice. So everything is wired up. And of course, they both use databases and so on. So everything is made up, built up. It just saw, that's why I had a warning message. It told me
we still need to wait for the NPM part to come.
And it just saw that I didn't build my Docker images for my microservice and my gateway. So my microservice was just built. So here my Docker image is done. And for the gateway, well, the Docker image is being done. Is that a good time for doing a coffee?
Probably.
Yeah, probably, because that can take some time. So my proposal is that we do a 20-minute break for the coffee. This will finish, hopefully.
And we won't cheat.
And we won't cheat. I will not touch anything because it seems to be working. And let's meet again in 20 minutes. Is that fine? Yes? Thank you. Okay, yeah, so we've got this little command on the top, jhdoc. This is the command I used to build my Docker image. So the question was, what is this command, of course? So first of all, if you go to the bottom screen, when I asked the JHipster Docker Compose generator to generate my Docker Compose configuration, it told me, you didn't build your Docker images. Here as the command to run it. So it's Maven package with a profile and with a Docker file build goal. So that's what you need to run. And when I run jhdoc, that's typically what it's running. So jhdoc is a shortcut. You can, of course, build your own shortcut, but this one is done using omyzsh. So if you are using Linux or macOS like me, you can use omyzsh. And let me just show you. And we've got our own omyzsh plugin. So it gives you lots of little shortcuts. When you have setting up your environment, shell plugins, we've got, well, 2 plugins, one for Fisherman and one for omyzsh, which is the one I am using. So it's managing your it's plugins for zsh. And it's helping you to have auto configuration for lots of tooling. That's what I'm also going to do when I will use Docker. I will have auto-completion with Docker. That's also an omyzsh plugin. So that's let's say external tooling, which is very good. And we have our own plugins for those. You see, here this is typically what I'm using with omyzsh. I'm using the Git, Docker, Docker Compose, and JHipster plugins. So you just need to follow that, and you will have the same commands as me. Oh, I'm just cheating a little bit to have things go quicker, like any good Java developer. You know, I don't run. I don't run this, in fact. I always add skip test. So it goes faster. It's a nice trick.
Which everyone should do.
No, usually I don't do it. I only do it for the demos, because otherwise it takes on forever.
Yeah, which everyone should do in demos.
So I built the Docker image for the microservice. I didn't do it yet for the gateway, because the microservice has got the entities. I need also to create them here. So I'm just going to do the same thing as I just did before. So I'm going to get the product. Yes, here is my microservice. We generate. I'm killing it because I know I don't need to finish it. Category. Yes, here it is. Regenerate. So this is building 2 client entities with Angular on my gateway. And I'm going to package this as a Docker application with jhdoc. And after that, I'm going to run everything here. So as it's going to take some time to build the Docker image, let me just open this up just to show what was generated with the Docker Compose subgenerator. It generated for me a full Docker Compose configuration. Oh, can you see it? Yes, it's working. So we've got our gateway, it's MySQL database. We've got our microservice, it's MySQL database. We've got console. We've got, so console config loader is our, let's say, trick to load Spring Cloud config configuration inside console. And here we have traffic. So those extends some other Docker Compose configuration. So if I take, for example, traffic, it's right here. So here you see we are using traffic 1.4, which is, it's not the latest version. They released 1.4.1 today, I think. So we couldn't upgrade right now. And console, Here it is. We're not using the latest version because I think it's 0.9.4, but it fails with Spring Cloud.
So we haven't fixed
updated
that part yet. So
yes, but that's normal because we know it fails. And so if you look at those two examples, you see also one of the interesting points of JHipster is that we configure everything for you, but we also test all combinations for you. If you were doing that yourself, well, you would have the bug, you would have to fix it, to roll back yourself, and so on. Here you've got a team of nearly 400 contributors, lots of people who knows all those very well, who is doing that for you. So there's a huge interest, a huge gain of time and effort if you use JHipster because all that testing, all that integration is done for you. So that's one of the main interesting things of JHipster is that it removes you a lot of trouble. So my Docker image is running. And here I'm just running Docker Compose up.
you didn't copy the D.
Oh, sorry. And so this is going to run my microservice, my gateway with console and with traffic. So as console starts up very quickly, I can already go there normally. Yes, console is already here. So this is what we had before with the JHipster registry, but this time it's console. So for the moment, no service is running. And we can go here to the key value store. And this is the little trick I was talking about. As you can see here, I've got my Spring Boot configuration, which is here. So that's what I told that was a little hack. So we are importing the Spring Boot configuration into the console key value store so that all applications are getting the Spring Boot config from console. So it's working exactly like the JHipster registry. And my app is not running yet. Oh, it's starting to run. Oh, another thing that started up pretty quickly is traffic. So if I go there, you can see traffic. You can see stuff already appearing here. So traffic, you've got two screens. This is the routing screen, and you see that if you go to /service, you've got your microservice, and you got here else screen. Well, for the moment we didn't do any it, so there's nothing yet, but we will be able to see our HTTP request here. So everything is coming. We can see them here. If I come back here, everything is running. So I can go to see my app. So another thing with JHipster is that by default, we always use the default configuration of each tool. So let's say it's a philosophy we have. So by default, when we run the application, we use port 8080 because that's what Spring Boot and Tomcat and Undertow use by default. But when we use traffic, it's the same thing. The issue here is that traffic also uses port 8080. So and by default, it routes requests on port 80. So that's why we are using it. I find it a bit misleading, but that's how traffic works, and so our philosophy is not to change it. So between using the JHipster registry with Zulu and traffic with console, the difference would be that in the other setup you can access each one at localhost with the port, whereas here you would have to go /. Oh yes, and the context also. Yes. With the context, which is provided by traffic. So you would have to go /gateway, /service, whatever user microservice name, which you don't have to do in the other setup. So let's go to the gateway. So it works. Whoa, good demo. So let's sign in, and let's go to our microservice just to see that everything is running. Let's create a new pizza. Yes, it works. So here, what's happening here when you go to /gateway? So you first go to traffic, which is here. Traffic /gateway is here is getting to our gateway, to Zulu, basically. And then the JHipster gateway routes the request to the microservice. So this is typically this schema, which is happening. If you want to use this schema with traffic handling directly the request to the microservice, where it works the same, it's only an issue of context. In fact, my service is here. Service. And it's just a matter of modifying the context. So in JHipster, by default, we have a relative context, a relative path. So it's very easy to
So
move it.
Yeah.
If you don't like it, it's a constant in
the front end. So you can modify it in the front end code, where you're talking to your backend through the Angular services, you can modify it to remove the relative context, and you can route them directly to your service. So both pattern. By default, it works in the second pattern we showed, but you can easily switch to the first pattern if you prefer that way.
Yeah, that's very easy to do.
Yeah.
One or other pattern depending on what you would rather do. And so, well, basically that's it. We've got traffic running, we've got console running, and our app is running. So,
so the only thing missing in this this alternate setup is the shiny dashboards, the API aggregation, the Swagger aggregation, the metric screen, the config screen, the logger screen, the log screen. Those are custom built in the JHipster registry, which are not present here. So
oh yes, but we'll see afterwards. We've got the JHipster console, which kind of does the same thing.
Yeah.
Well,
so there are more options for that.
We will see some alternatives for that also. So let's stop everything because that makes much sense to keep everything running. And let's talk about security. So it's a topic we already introduced, but we didn't detail the different security options. So here is the time to see that. First thing about security, HTTPS. We've got, of course, HTTPS support, which is built in with JHipster. Oh, sorry. If you see our Spring Boot configuration, we've got a full documentation about that. It's very easy. You just generate a...
Yeah, you can. It's basically just, uncommenting some part in YML file, add your own Let's Encrypt certificate or something, and you're ready to go HTTPS. So it's very easy to do.
Yeah, I'm opening it into IntelliJ. We'll show you when it's opened. HTTPS is also, well, it's important for security, of course, but it's also important because if you want to do HTTP2, you need HTTPS. It's not a requirement in the specification, but all browsers that have HTTP2 support require HTTPS.
Yeah.
So
and we support HTTP2 configuration as well. It is commented on by default, but we can enable that as well.
Yeah, well, let me show that to you. If you go to our Spring Boot configuration, so in resources config, if we go to, where is it? It's here. So to enable SSL, we give you the line to do with the key tool, and then you just put so the SSL port, the key store, and so on. So you just uncomment that. You run the command and you uncomment that. And if you want HTTP2, here you've got JHipster HTTP version instead of 1.1. You just put 2. And if your IDE is cool, like this one, whoa, it should autocomplete. Well, IntelliJ is not as good as it's supposed to be. I don't know why. Oh, it's indexing. It's not finished. Okay. Normally, IntelliJ, once it has... Oh, yes, sorry. It's my fault. I didn't commit... Oh. So that's another interesting thing with JHipster. So normally with JHipster, we push always to commit everything into GitHub, into Git. Here, I didn't do it. We've got all the default configuration for Git. And if you do that, what's interesting is that your IntelliJ understands that node module is an ignored repository directory in Git and will not index it. As I didn't do it, well, IntelliJ saw that nice directory and started to index it.
With millions of files.
Yes, node module is awful. So it just hung everything up. So now I have extruded it. It should work. Yes, it should work. So you just put v2 and you've got HTTP2. Those configuration, as you see, it's fully documented. It's also fully documented on our website. And this is a specific JHipster configuration. This is not by default in Spring Boot. It is what we add to Spring Boot. So we have lots of things to Spring Boot, but in particular, we have HTTP2 support with HTTPS. So with HTTPS, also we got some other options that just securing it with the Spring Boot. Some people, first of all, only secure gateways because they consider that the microservices are into your internal infrastructure, so should not be secured. Why not? I mean, it's
if you're using an aggregator pattern, it kind of makes sense because you have your entire data center, whatever, already secured, supposed to be secured.
Yeah.
So you're only exposing the gateway to the outside world. So it's good enough if you secure that well.
SSL is
But
also adding quite a lot of little performance hit. So maybe you want to remove that. I don't know.
But again, it depends on your business choices and the choices you make. So
Yes.
of course, if you don't worry about the performance overhead and if you think that your infra is not secure enough, then of course you can enable security and HTTPS on everything. So.
If you don't want to do it with Spring Boot and Undertow, you can use it with traffic. That's one of the good reasons to use traffic is that it supports HTTPS and it supports Let's Encrypt.
Yeah.
So with traffic, it's very easy to secure everything. So one very good reason to have traffic in front of JHipster architecture. And yes, and as I just talked about Let's Encrypt, so you probably all know about this. They provide free SSL certificate. It's really great. The only downside is that your website needs to be publicly available. But that's a very good solution. In fact, that's what I'm using myself. If you go to JHipster Online, you see it's secured. It's secured with Let's Encrypt. I have no idea what this is written. In the Chrome DevTools.
They keep moving it.
Anyway, valid certificate, Let's Encrypt Authority. Yes. Oof. So this is done by Let's Encrypt, and in fact, here my front end is Apache. I just used Apache because there's an easy-to-use tool to generate and renew your Let's Encrypt configuration with Apache. Thank you, by the way. So that's very easy to do and free. So that's a great solution to secure your app without spending any money. So HTTPS was just the protocol. Now how do we secure our architecture? We've got three main options for microservices with JHipster. The first one, which is the most popular, but it's also, because it's the oldest one, it's also the easiest one, is the JSON Web Token. So it's totally stateless. You've got a signed token that all microservices and gateways share and trust. So it's very easy to understand. The code we generate, if you want to have a look at it, it's very, very simple. Yes, with JHipster, we've got libraries. Here, it's not a library, it's something that is generated because we know you want to change it. You want to add claims to modify it, but it's very easy and simple, so that's why people love it. There's just a couple of issues if you want to be really secured. The first one is that the default algorithm is not the most secured one. It's honestly enough for everyone, but if you want a better one, you should add Bouncy Castle libraries.
If you're NSA, it's not good for you. So.
So you can have something much more secured with Bouncy Castle. And by default, we use a shared key because we deploy it using the JHipster Registry or console, which is good enough. But if that's not good enough for you and you want to do public-private key encryption, well, you can also easily do it. But then there's more setup to do.
Yeah, it's a bit more complex to do.
Yeah. So those are the two good tricks if you want to have better security. But the default security is already good enough normally. We have tons of users doing that.
I think JWT is the most used option out of all the security mechanisms we provide.
Yes.
Because it's the simplest to use and it's
and simplest to understand.
Yeah,
if you want to have a look, it's very easy to understand. The second one, which is in fact surprisingly popular, if we have time at the end, we will have a look at the stats. I will let you do it.
Okay. So another option we provide is our own UAA server. So it's a user authentication and authorization server. So it is again a JHipster application which you can generate along. So when you run JHipster, you have option to generate a gateway, microservice, and a UAA. So once you generate this, it provides a Cloud Foundry UAA application for you. So it handles security. It is much more secure than JWT option. It also works with JWT for the microservice itself. So easier to use when you have multiple gateways. So because it is easier to handle. Because normally in our JWT options, user management is handled in the gateway itself. But when you have several gateways, it doesn't make sense to have user management in each of them. So it's better to move it out to its own service. It's popular for microservice architecture where you need better security than JWT, or you have more gateways and stuff. So as I said, it has to be generated. It can be easily customized because it is a normal JHipster application, which is with a lot more code for security generated. So it also provides OAuth tokens for all your applications. So the architecture looks something like that. So you can see that there is a OAuth server here, which is of course our UA server, which works along with the gateway to secure your application. We also have OpenID Connect, I think.
Yeah, so OpenID Connect is our last option. We released it into our last release, so it's very new, but everybody wants it. We have very, very high demand for that. So two good reasons to use that. It's like JHipster UAA, and that's what Deepu said, that you've got several gateways, or also because you want to have something external, because it's more secured, because it's done by another team.
And also if you're a company with a lot of applications where you want to kind of do SSO kind of stuff, and if you already have a mechanism like Okta or Keycloak, then it makes sense to use that here as well with OpenID Connect.
Two of my big clients at the moment, they use OpenID Connect because, for the whole company. And at my company, we've got several customers with Keycloak, enterprise Keycloak for everyone. So OpenID Connect is an identity layer on top of OAuth2, so it's basically the same thing as JHipster UAA, but you've got, let's say, full applications providing it. It's great for microservices architecture because we've got servers which can aggregate security, several LDAP servers and so on. They can aggregate everything. They can handle social website authentication and so on for you.
SSO and all those things.
You can do SSO, so it's. It's normal. There is a very, very high demand for that. So the downside is that it's much more complex to use. The good thing with JHipster is that we did the hard work.
Yeah, and so you don't have to do that.
Very, very hard. Unless we have some bugs, honestly, it's as easy for you to use as JWT, and it's much more powerful. So that should be a very good.
The only difference
solution.
is might be slightly a bit more difficult to understand compared to JWT, because JWT code is hardly 2 or 3 files, 2 or 3 classes, and very simple to read. Where this one is a bit more complicated.
Yeah, and the setup is a little bit more complex, but that's kind of okay. And so today we support, so OpenID Connect is standard, and we support 2 implementations. We support Okta, which is a company from Matrable, with a person who, is a core JHipster developer, is the one who wrote the JHipster mini book, which is for the moment the only JHipster book, until your book is printed. So Matt works for Okta and did the original Okta implementation. So that's very interesting because it's the business of his company. So obviously it should be some very secure and well written code. And so we support both Okta and Keycloak. And why do we support both? Because they are the 2 most popular.
And both are OpenID. They both support OpenID standard.
Yes, because that's also another thing with JHipster. We want to not to be linked to one implementation. So when we talked with Matt, we told him, okay, for OpenID Connect, but we want 2 implementations to be sure that, we can switch. And if you have another implementation, I know, I have a client who uses ForgeRock.
Yeah.
I don't know how this implementation works, but it's another OpenID Connect implementation, as we already support 2 completely different implementations that should also work with them.
So technically, any OpenID supported authentication server should work.
Should work, yes.
With little configuration changes.
And so this works very well for monoliths. For microservices, it's a bit more complex. But I think that today we've got something quite good. Yeah. In the latest release, which is what I'm using it, we have nearly everything working. I know one little bug, but it's very small. You will not notice it. It's already fixed. So in the next patch release, it won't be there. Honestly, it should be good now. But if you want to use it in production, maybe wait a little bit.
Yeah, few more releases.
Yeah, a couple of releases, but honestly, it should. It's starting to be good. And I wanted to do a demo of OpenID Connect as we got time.
Yeah, we have time.
Yeah, let's do the demo. So let's do it again. Yeah, so this time, let's use, I'm just changing just to have fun. let's use microservice application. Let's call it key clock service. So it's using the JHipster Registry. It's using OpenID collect this time. Yeah, let's do it like that. Generating it on GitHub. It's here. Let's clone it. So git clone. We got it. Now let's do the gateway. Key clock. It's quicker like that, like this. Then I need to clean up my GitHub account. Key clock gateway. OpenID connect, and everything else by default. Copy. Git clone. So cd key clock service. Let's do the Docker image, chdoc. And for the gateway, key clock gateway. Oh, I need first to do yarn install to download the npm dependencies. So this is going to take some time. And then I will do a Docker image again. And here, with my Docker configuration, I'm going to run it again.
You will be running the Docker image with pprod, so you actually it will run install and everything anyway. So
yeah, well,
yeah. So you could directly do it as well.
I'm just Docker. Yeah. Oh yes, I could. Yeah. Oh, okay. Let's do it like that. There are several ways to run it. So it's just, let's do a microservice with Zulu. And so this time I'm not using traffic, I'm using key clock. So I'm selecting my gateway and the service I just generated. Let's do it. Docker compose up. Just need to wait a little bit until this is downloaded. Maybe we can move on. And we'll
build it again, right?
Sorry?
You have to build it again, right? This is
yes, but it's downloaded, so we can.
Yeah. Okay.
Let's not wait. I think we can do the rest of the presentation.
Yeah.
And we'll come back until it's downloaded, and we will see that we have a simple gateway, a simple microservice, and everything is authenticated by key clock. So you will not have the user management. Which is part of the JHipster gateway normally, and we will be redirected to key clock. We'll be authenticated there, and everything will be running. Where is it there? It's taking forever, so let's move on. A little bit, I will come back just to see. So we talked a lot about architecting our microservices, about the different parts that we could move, how we could secure it. What we didn't talk about at all is monitoring.
Yeah. And in a microservice, that's very important.
That's probably the most important thing in microservices, because you're going to have tons of services, you're going to scale them, so you absolutely need to know what's going on. We already saw that in the JHipster registry, we've got some basic monitoring. It's
like metrics and health monitoring and all those stuff. But
it's good for development because you see the issues.
Yeah.
In production, it can be useful.
But you need more.
But it's not perfect for production. Biggest issue is that, the good thing is that it's live, because the live data, but the bad thing is that it's not historical data.
Yeah. So it doesn't, the metric registry, the metrics we use is from Spring Boot Actuator, which doesn't persist it. So you don't have historical data to analyze and find patterns or anything like that. Yeah. So
it's good, but not good enough. That's what we just saw. We've got metrics, else, the logs, live logs. I showed it at the beginning. We've got the Spring Boot configuration. You can change log levels at runtime. I showed it at the beginning, so let's not do it again. What is interesting with what you've got by default with Spring Boot is that it's fully secured, either with JWT or OpenID Connect, or
depending on what you
depending
choose.
on what you choose. There isn't JHipster URA, and it's an issue. I did not know that. I just discovered it. So, but the important thing in comparison to what you have by default with Spring Boot is that it's fully secured. And fully secured with the security option you selected. So it's like really with the rest of your architecture. Yes, it's done. Let's do the Docker image. And I'll come back just after that. So let us introduce you to the JHipster console. So this is based on the Elastic Stack. So the Elastic Stack is Logstash, Elasticsearch, and Kibana. So it's very well known for people doing monitoring. We did tune it quite a lot. First of all, we tuned it in our Spring Boot application. We send, first of all, we added the metrics using Yammer metrics, drop wizard metrics. That's the new name.
Wizard, yes.
So we have a lot more monitoring than what you have by default with Spring Boot. But we also tuned what was being exported. We export it in the right format and we directly on the network with TCP to Elasticsearch, to Logstash. Yeah. So basically, Logstash has got nothing to do. Normally it has got to take your log file, modify them, send them, and so on. We just get.
So we made sure when we stream the logs to Logstar, we already made sure that it is optimal. Yeah. So then Logstar takes care of aggregating that and putting it in the Elasticsearch. Yeah.
So there was a big work here to optimize Logstash. And second thing is that we provide a lot of built-in dashboards, so we will see them in the demo. Because as we already know, now you use microservices with EHCache, with I don't know,
Hazelcast, Infinispan, or whatever.
We know that what you are going to use, so we generate the correct dashboards, so it's already done for you. It's a normal Elastic Stack dashboard, so you can do whatever you want with it. You can add your own dashboards and so on, but you've got already pre-made dashboards, so it's a lot easier for you.
You can also configure Elasta Alert on top of that if you want. You can do whatever you can do with the Elastic Stack. You can do on top of what we provide as well. We just make sure that we provide something which you can already start using. We don't provide a bare-bone Kibana where you have to go and look for everything. We provide something which you can already start seeing stuff. Then you can obviously do all stuff that you can do with Kibana and Elastic Stack in general.
And so compared to the JHipster Registry, the interesting thing here is that we aggregate all applications and all instances of all applications, and we store data over time. So, of course, it's much more interesting. Let me just go back to the Keycloak demo because the Docker image was done. I started Docker Compose, so everything is starting to run. So let's have a look at our Keycloak architecture. So first of all, let's go to the JHipster Registry. So, already, straight away. So I went to the JHipster Registry. It saw that I was using Keycloak. It redirected me to Keycloak. Keycloak, so by default, it's the same login password as usual. So it's admin. I'm logging in. I'm coming back here. So as we just said, it's fully secured by Keycloak. I can go to Keycloak here just to have a look. Sorry, it's in port. No. I think it's this port. Oh, sorry, it's the opposite.
98.
Yeah. Administration console. So if I go to Keycloak, we've got already JHipster configured here. And it says already we've got a session here in the JHipster registry that is opened. We just opened at the moment. So as you can see, we already have our old JHipster realm in Keycloak with the users as the roles. Everything is already done. And the JHipster registry is using it already. So everything is running. Let's go to the gateway. Sign in. So this is basically the same screen as before, but when I click sign in, I am also redirected to Keycloak. Oh.
No, because you're already logged in.
Yes, so it went so fast. I was automatically logged in by Keycloak. Let's go back here. In fact, it's going so fast that the demo is Go to the web app. Oh, I didn't know this one. Hang on. Session, logout all. That should be good. Let's restart. Ah, created it. No.
No, it's still
no,
the
sorry.
token,
Yes,
so
it's stateful. Okay, it's going to take some time. I didn't want to go through all that. So Keycloak uses, since OpenID Connect, which does that. It's a stateful mechanism. So it's going to work for, I don't know, a little time.
Yeah.
And then
because the token is still valid here?
Yes, the token is still valid. It will
Doesn't
try
automatically invalidated yet?
to refresh the token. If I sign out here, this time I'm signed out in my app and in Keycloak. So this time it's going to work. I'm redirected to Keycloak. I am logging into Keycloak, and I'm going back. I don't know if that's... and of course, everything works. And if I go... Oh, I didn't generate any entities, but you need to trust me. If I was clicking on some entities, the Keycloak token is transferred to the microservices. And that's where a big part of the hard work was done. It was done by Daniel Petsims, which was a French developer.
But I think it already would work pretty similar way when you do this as well, right?
Ah, yes. I'm not sure this one works. If it works, that's cool.
Technically, it should.
It works?
Yeah.
Oh, okay.
So
I'm learning
it is
stuff.
fetching from...
I think I coded this, in fact. But so here, of course, we are accessing the microservice. Thanks for this good idea. And as it is, for example, as this one is secured, you can imagine that when I go there, it is sending the correct token to the microservice.
There is even two special ones, offline access and authorization, which we don't, which is not from us.
I don't know those ones, yes. those come from Keycloak.
Yeah. We configure only role user and role admin, so Keycloak is adding two more special roles.
So what happens here is that the gateway is authenticated by Keycloak. Keycloak gives it a token. The gateway sends the token to the microservice, and the microservice trusts the gateway, the Keycloak, so it accepts the token from the gateway, and everything goes through. There is also quite a lot of work here because, so by default, what we just saw is that it is a stateful mechanism. So on the gateway, it's working fine, but the microservice is not stateful. The microservice, you can scale it. It's stateless. We're going to talk about stateful versus stateless very soon. And so that's an issue because by default, if you use Keycloak and Spring Boot, what's going to happen is that Spring Boot is just going to ask Keycloak for every request, do I trust this guy? Do I trust this guy? Where is he? All the time. So there's a specific Keycloak endpoint, which is called user info. It's going to call it all the time, so it's not going to scale. With JWT, you've got a token with everything inside the token, and it's signed. So the microservices trust the token, open it, and everything works fine. But with Keycloak, it's not the same thing. So the microservice always goes back to Keycloak to ask. So that's, of course, a big performance issue because it just doesn't scale at all. So what we added here is a specific cache. So we have our own cache to cache tokens on microservices. So we don't ask Keycloak all the time if the token is valid. All this works because JHipster also manages the cache for you. So if you selected Hazelcast, you got distributed cache with that working, without doing anything. And that is the default option, just working by default. This is one of the strengths of JHipster because you see we have everything integrated. We've got Docker, we've got Keycloak, we've got Hazelcast. Everything is, and we've got the Angular frontend. Everything is tightly integrated together and works fine out of the box.
Probably this is the fastest way to set up Keycloak
that
I know of.
Yes, if you don't do that, good luck. Something for traffic. Yeah. Traffic, well, no, Keycloak is worse. Keycloak, you need several weeks.
From scratch, I have tried.
I have no idea why. We were 3 teams. We did a little hackathon at work. And we were 3 teams. Only 1 team succeeded. I didn't succeed. And each of us had 1 day. And we took the winning solution. So if you do it, maybe if you're lucky, you will need 1 day. If you're unlucky, you win one of the losing team. So the interesting thing here is that it's already working for you. So you win a lot of time. And if that doesn't suit you completely, as you see, we've got lots of options, lots of configuration. You can tune stuff. But it's a lot easier to tune something which is already working.
I mean, there was already a proposal to move the authorization part to the client side.
Yes.
But there are discussions like where it should be done on the server side or the client side, and there already people are trying to bring in a lot more other options into this.
Yes, and this is an interesting option, but I don't know what we will do. So back to the JHipster console, because to store data over time.
We have a demo for that as well. And
yes,
we have time.
Yes, we will have time for the demo for that.
Okay.
More options.
Okay. As we said, more options. Yes, we pretty much cover everything in the microservice world, I guess. Almost.
Yes.
Yeah.
Sure.
So as is our motto, we always give options for anything. We don't try to go into one particular solution and lock in there. So since we offer elastic stack as JHipster console for monitoring, we offer Prometheus as an alternative as well. So you can choose between JHipster console or Prometheus. So if you're choosing Prometheus, which is a commercially supported. No, it's not commercially supported, sorry. That was the other one. So it is also open source. So it is an alternative to JHipster model console. The advantage compared to Elastic Stack is that Prometheus offers multi-dimensional data, and they out of the box they support time series very well. They have very flexible queries and Grafana-based visualization. So if you don't like the Elastic Stack, then you could try Prometheus, which has Grafana, which is very good for time series visualizations and stuff. And it has inbuilt alerting. You can also do alerting with the JHipster console, but then you have to use Elasta Alert. You have to configure that. Here it comes out of the box. It is written in Go, which I was told that better than writing in Java. Yeah. So it also goes with console traffic and this all written in Go.
You can have the full Go. Infrastructure if you like Go, if you think it's better.
Go platform.
Because a lot of people I don't know.
Go-to platform, is it?
Yeah, well, lots of people in the infrastructure world love Go.
Yeah.
Well, the only feedback I can give you is that when I build my stack with console and traffic, it uses a lot more memory than with Java.
But starts up faster, I guess.
It starts a lot faster, but it uses a lot more memory. I don't know why. So just the default setup uses a lot more memory. But otherwise, it's faster, and you got some. It also fails better. So it's yeah.
Yeah, it's like a trade-off, I guess.
It's really choices. Yeah. I have no recommendation for that. No, for myself, I'll use, as I'm a Java developer, I'd rather use the Java tools because I'm not lost with them. If I want to tune them, I can tune them. But that's all.
With JHipster console or with Prometheus, we also offer Zipkin as an option. So when you generate the Docker Compose setup part, you can enable to use Zipkin. So Zipkin is a distributed tracing system. So it collects your timing data. That means from your logs, it collects your timing data and all registered services or your microservices, gateways, and everything. So it sends your timing data to Zipkin, and Zipkin creates a dependency diagram based on that timing data. So by analyzing that, you will know where you're losing time. You can trace performance issues and stuff like that. So it also helps to troubleshoot latency issues in microservice architecture, which is very important because once you have a lot of services running here and there and a lot of moving parts, it will be very hard to track or trace where stuff is going wrong. Or if you have a performance issue with a lot of microservice in between gateways and all these things, it becomes very difficult to track where you have to tune. So Zipkin helps there because it builds a dependency tree and tells you exactly where to look, so you can start tuning that part. So it also supports so this can persist the data. So it can either persist in memory, or it can support any of the commercially available or non-commercially available as well. Like it can support MySQL, Cassandra, or Elasticsearch for storage. So it goes very well with the monitoring solution. So you can use it with console or with Prometheus. We auto configure this and provide Docker images for this as well when you choose this option. Next is about scaling microservices.
Yes, so as we talked about monitoring, we're going to talk about scaling. Of course, it is linked.
Yeah.
And that's why we will have a demo with everything after that. So the first issue about scaling is being stateless or stateful. We just talked about it a little bit earlier, and I said we were going to detail that. So scaling a stateless application is very easy. That's why people always tell you to be stateless. And that's why JHipster by default uses a stateless design as much as possible. That's what we have with JSON Web Token, for example. With JWT, we are fully stateless. So it's grid, and if you want to scale, you just run more instances, and it works. Of course, one of the issues is that the instance need to see each other and so on. That's what we do with the registry and so on. So there's really no issue with JHipster for that. Unfortunately, sometimes you need to be stateful for, well, usually there are two use cases. The first one is security. We just saw it with OpenID Connect. The other one is caches. What's going to happen, and we'll talk about this just after, we're going to see that when we want to scale a microservice which is on top of a database, well, you're going to have a cache and you're going to want to scale the cache. So typically this is going to be an issue because this is going to be like to handle some stateful data. It's bad for scaling, but it's necessary, and we're going to see how we solve that problem. There's a usual solution for that when you do a monolith, is that you do sticky sessions. It's a very usual solution. I remember first time I did it was like 20 years ago.
It still works.
I even wrote the original documentation for JBoss on sticky session, like JBoss 2.2, something like that. So that's very good when you have a monolith. You've got one big JBoss server. The issue with microservices is that maybe you can have sticky sessions on your gateways, but then your microservices don't have the sticky sessions. And imagine that if the microservice calls another microservice, you're going to get sticky sessions.
I think Hazelcast kind of supports distributed.
Or you get distributed HTTP sessions. So for the gateway it's good, but not for the microservices.
But still not good enough.
It's not. Yeah, it's just basically not going to work very well. It's a good solution, but for microservice it's not good. Well, it's not good enough. But anyway, the biggest issue is scaling caches. Even for security, because as I just told, for OpenID Connect, we also store this in a cache. So basically, it's just scaling caches. How do you scale caches? Well, we've got 4 caching options with JHipster. The first one is not using any cache, so it scales very well for your app. The bad thing is that you send all the load to the database, so your database is not going to scale. That's what I see in a lot of conference talk. People just don't care. Put everything to the database, but your database is just not scalable at all. So then people tell you, yeah, okay, but I'm going to use a NoSQL database. But if you use a NoSQL database, you won't have the relationships and so on that we just showed. So you lose a lot of goodness from relational database. And also, I'm using a lot of MongoDB for a client. I'm not sure it scales that well in the end. At least it's not easy to back up, and you can lose data very easily. So it's not good for everyone. But so, first option is not using any cache. Oh, and by the way, JHipster support MongoDB. We've got like 15% of people using MongoDB with JHipster, so it's quite popular.
And Cassandra.
We support Cassandra, but unfortunately, because I love Cassandra, I just totally love it. But we have got very, very, very few people using it. So maybe at one time we'll have, I don't know if we will drop it, I don't know. It works very well, but very few people use it. And we should support Couchbase anytime soon.
There's already a PR in the work.
We've got a PR. We've got at least 2 projects working, because there's 2 people I know from different companies. There are two projects using it in production, but we still haven't had time to merge this pull request. It will probably be in the next release. Well, it will be in the next release, because I promised the guy. I work with him tomorrow, I think so. I promised him so. So first option, no cache. Second option, EHcache. So EHcache is the world default cache usually for monoliths. It's very popular. It's very good. It's like everything is good. It starts up very quickly. That's also why I like it better than Hazelcast and InfiniSpan. You have a better startup time. The issue with EHcache is that if you want to have distributed cache, you basically have 2 options. The first one is to do network broadcasting, which is like forbidden in most companies and doesn't work with Docker, and so it just won't work. The other option is that you've got to list all the IP address you are going to use. So of course it's not going to work because we want to scale live. So no option works. So unfortunately we have no good option for EHcache. And if you want to scale, to have distributed cache, we've got 2 very good options. The first one is Hazelcast, which is our original option, which works very, very well. Which can also do HTTP session clustering. So that's what we just talked about. I'm not recommending it by default. If you need it, use it, but if you don't need it, don't use it. And we've got InfiniSpan by Red Hat, which basically works the same as Hazelcast, just a different solution from a different company, but both are equivalent.
One fun fact about the caching solutions are each of them were implemented by the...
yes, but the company doing it, yes.
Yeah.
That's, well, one of the very good, what's very good with JHipster is that we've got companies contributing. So cache code, well, I coded the original version, but it was recoded by the people from Software AG, so the people doing cache. Hazelcast, I also coded the original version, but it was recoded by the people from Hazelcast. And InfiniSpan was coded by one of your friends who works from Red Hat. So each option was coded by the company doing the caching solution. So you can imagine it's probably better than what you have coded yourself. So what's a good reason to use a code generator is that you're going to have code written by the people using the caching solution, which is probably better than the code you would write yourself. Well, at least
most of the times.
I let them delete my code and put their code in place of mine because that's what I think. I think they are better than me. And we got some added bonus with both Hazelcast and InfiniSpan. When you add nodes with, we'll see, we'll use Docker for that. When you add new nodes, so they all join the same cache. And if you have Hibernate or that kind of thing, everything will work out of the box.
Yeah. They scale very well.
Very well. Well, we will show it in the demo because we have time for the demo. And so how do we scale? We've got lots of production options. We'll talk a little bit on production afterwards. But the easiest thing and the easiest way to scale on a laptop is to use Docker. So I'm going to use the JHipster Docker subgenerator that we already used. And I'm going to scale some microservices. And well, you will see that the cache works automatically. Failover, we just talked about scaling, but before doing the demo on that, of course, you scale, but you also unscale. You have failover sometime. When a node fails, it is managed by your underlying cloud infrastructure. So if you've got an auto Kubernetes, it's going to pop up a new node and handle it. The service discovery mechanism should alert the other services and handle everything, all the failures. So the issue we talked about with Eureka, and we will see it when we will make it fail, is that Eureka can take a few seconds, 30, 60 seconds, quite a lot of time to remove an old node. Why is it so slow? Is that in its current version, the next version is supposed to change, but it's not out yet, and they're taking a long time to release a new version. The current version, Eureka replicates everything in all nodes. So all nodes have got the full dictionary of services. So if you've got 500 microservices, it's not a very good idea to replicate 500 microservices all the time. So by default, the timeout is quite big. If you've got less, I don't know if you've got 5 or 10 microservices, you can have a smaller timeout so that you replicate quicker. But if you've got hundreds of them, it's just going to be too slow and blow out your network for nothing. So this is the reason why Eureka has got some very big timeout. With Consul, so it's going to be much quicker. Basically, it's immediate. You have it immediately. And then HTTP request routing should handle those failures, of course. What I mean is that even if Eureka, you are in the 30, 60 seconds when Eureka hasn't seen anything, so you are hitting a server which does not exist anymore, well, your HTTP request routing mechanism should handle that failure. So we did a specific tuning on the gateway for that. Basically, it's the statistics. And if you use feign, so if you use feign to access a microservice from another one, well, you can configure a fallback. So feign should handle the failure, but you can also tell it, okay, this thing is feigning. Well, let's do something else. So we're going to do a quite complete demo from the two previous parts. We're going to see monitoring, scaling, and failover. So are all linked together. So that's why it's a nice demo for everything. I will do I will reuse the gateway and the first 2 microservices we did at the very beginning. The simple hello world, the real microservice, and the real gateway. I will configure everything with Docker Compose, which we have already done before. But this time I will use the JHipster console to monitor, and we are going to run it and have fun with it. So let's stop what we had before. Come on. Well done. Yes, when I use the JHipster Docker Compose subgenerator, as you see, so I can do Docker Compose for Monolith or for microservices applications. So of course, I'm using microservices. It's going to ask me where all my microservices are. So it's in my Python directory. As you can see, here we see all the projects we have done because it's scanning everything. So it sees gateways and microservices. And it remembers my last choices. So the idea when you are a developer is that I'm only working on this and this and this. I have my custom code I can work on. And then the final app, maybe you will have everything. Yeah. So it's a great tool for developers who want to test microservices. When you work in a team, you're working on the gateway, and you've got 2 microservices from other team. You just select them, and then you pull the images from them, and you don't even know what they are doing. But for you, it's all packaged for you, and you don't even know it works. But you can already use it. So it's the gateway, microservice, and online shop. So this time I will use the JHipster console. As you can see, like Deepu said, you can choose Zipkin here, Prometheus here. We have 2 more options. So you talked about Zipkin, which is really a must-have if you want to see the flow of your HTTP request. But you can also use Curator, which is something which is cleaning up Elasticsearch index. Because the issue with what we do is that it just puts everything into Elasticsearch, and at some point you need to clean it up. Not going to use it because you only had 3 hours. Up. And it's telling me I don't have my Docker images for that. But it should be there because we did it before. Oh, no, maybe not. Oh, no, I never did it. Oh, okay, sorry. We've got tons of Docker images to do. I should have done it.
Because we ran them locally.
Right. -doc. Gateway, I should have done the gateway before.
No, JH.
Express, Devoxx, online shop, JHdoc. Okay. I'm just building the Docker image for everything. Yeah, I didn't do it at the beginning.
Yeah.
We introduced Docker afterwards. And so it's building the 2 microservices, it's building the gateway.
The microservices will build faster.
And let's come back here. And once everything is built up, I will just run Docker Compose up, and everything will work. Is it quick? Yes, we're going to need 2 things built. Just one to wait. Yeah.
That one is running the Angular compilation, so it's going to take...
It should be fast.
30 more seconds.
Yeah, a few seconds. I'm just introducing what we'll do next. Just give it some time. Once we have... Oh, so it's you.
Okay, so by the time we finish, let's take a quick look at what we do to support continuous delivery. For continuous delivery, you need good testing infrastructure and testing support. So we support a lot of testing options. So on the server side, by default, we generate a lot of JUnit tests. We also, JUnit, of course, is the de facto standard in Java. So we do generate a lot of that. So you can run them based on what you have chosen, Gradle or Maven. You can run them using the default test tasks. So we also generate a lot of Spring integration tests. They're also returned with JUnit, Mockito, and Spring test context. So we do this only for the REST endpoints, or the REST resources. So we generate integration tests for them. So Mockito is also very excellent for mocking and creating spies for your services and endpoints. So you can also run these using Maven test or Gradle test. So they run in-memory versions of whatever database you use. So we also provide in-memory database for Mongo, Cassandra, and Elasticsearch when you do the testing, which is like very unique. Yeah. So you can run integration tests, and on the server side, we also generate performance tests. So the JUnit test and the Spring integration tests are by default generated. They are not options.
I'm just running it.
Yeah. So they are not options, whereas the performance test using Gatling is optional. You can choose to enable them. So Gatling is a Scala framework, which is very good for load and performance testing. So Gatling tests are generated for entities. So we use the Gatling Scala DSL while creating the test suites. They also provide very good visualization using high charts once your tests are done. So it is very good to analyze how your application is performing and stuff. So you can also do load testing with it. So I think this is one of the go-to tools for performance testing these days.
Very, very good tool.
Yeah.
It's done by a French guy.
Okay. So yeah. So you can use Maven or Gradle to run them and select appropriate test suites and execute them as well.
Yeah. Oh, by the way, with the Gatling, as we have security, we handle JWT token for you, for example.
Yes. So
I wonder if it works with OpenID Connect.
That would be nice too.
Yeah, I'm not even sure it works.
I think it works because
it should work, yeah.
Yeah, Matt did some tests on
that.
So
yes, so it should work. Yeah. Because if you don't use JHipster, then first of all you need to learn the Scala DSL, which is not that hard, but people are often frightened by it. But the biggest issue for me is that you need to handle the security. And well, that's done for you.
So by default, all the tests they work with whatever security options you choose. We make sure that it works with we make sure everything works out of the box.
Yes. So depending on your options.
Yeah. So for BDT tests, we provide Cucumber support. We don't generate a lot of Cucumber tests. We provide the infrastructure for that. We configure Cucumber. We put in all the libraries and stuff. We generate a sample test case, but we don't generate tests for entities yet. But you can easily, because for BDD testing, it's mostly driven by your business needs, and this is supposed to be a business test cases, so it's hard to generate them. So tests are returned using Jerkin. You can also, this is also optional, you can choose it while you generate the application. These are on the server side. On client side, by default, we generate Karma and Jasmine units. So Karma and Jasmine unit tests. So tests are returned using Jasmine, and they are run using Karma. This is one of the most widely used unit testing frameworks in the Angular world, and otherwise as well. So you can run them using yarn test command. For E2E tests, we also support Protractor as an optional item. So you can enable Protractor. Tests are again returned using Jasmine and run using Protractor. So it is default testing E2E testing framework for Angular because it's from the Angular team itself. It also supports parallel testing, having test suites and a lot of stuff. You can also use, so this uses Selenium WebDriver. That means you can also use it with Selenium Grid. So we use it in our company, Selenium Grid, so we can parallelize the tests and stuff like that. So it's very good when you have a lot of tests. So it is very nice. Most other testing, E2E testing frameworks like Nightwatch or there are a few others. They don't. Most of them don't support Selenium Grid. So this is a very good advantage. If you are in a company and if you have Selenium Grid, then you can run hell lot of tests parallelly on all those Selenium Grid instances. So this is run using Yarn E2E. For Protractor also, we generate entity E2E tests as well as some of the other application side E2E tests as well. So we generate quite a lot of E2E test cases for that.
This is very important, yes.
Yes, this is very important.
What people love.
Yeah.
And your manager love it because it's all graphical, it's shiny.
Yeah. So once the testing part is taken care of, we also have CI/CD subgenerator. That means you can generate your pipeline using JHipster as well. So currently we support Jenkins, Travis CI, GitLab, and Circle CI. So once you fire up the subgenerator, it will ask you what kind of pipeline you want to use. You can choose it, and it generates a configuration file for that. For Jenkins, it generates a Jenkins pipeline. with all basic steps like compiling your application, building your application, testing your application, running ETU tests and stuff like that, and even deploying. If you are choosing Heroku, currently we generate steps to deploy as well. For other cloud providers, we don't support that yet. Currently, only Heroku is supported. So you can still generate the basic pipeline and you can customize as per your needs as well. So still have the templates there for you. So now we can see how we can go to production along with the other demo.
And if we have time, I will do a little CI/CD.
Yeah,
we'll see.
Yeah, we can do that.
So, connection. Hang on. So this is an issue. I guess Docker crashed.
Yeah, so I was wondering how can a demo go without issue?
Docker crashes very often. Honestly, the Docker for Mac crashes very often. So I'm not too surprised. I'm just restarting. Should not crash in production, but anyway, that's Docker. It's supposed to be the future. So I'm restarting everything. Well, as it can take a little time to restart, we can do a little CI/CD if that's good. Travis CI. So, that's good. You remember I generated an app, which is, where is it? Your profile. I generated several apps. Repositories. So the first one, the Hello World. Where is it? Microservices. Yeah. So I generated that app at the very, very beginning. You see, 3 hours ago. Let's go to that app.
3 hours ago?
Yeah, well,
seems like we have more than 3 hours.
So here it is. And I would like to make it work in Travis. So basically, let's say, oh yes, I added, you remember I added the controller in it. Git commit YOLO. I always git commit YOLO. And now I'm going to do JHipster CI/CD. I'm going to ask it to generate for me a Travis CI build.
You should use GCA for it. You should use GCM for that.
And no, I'm not going to deploy to Heroku. So this generated for me a Travis build pipeline. I'm just git commit Travis. So now, if I come back to my app,
you need to push it, right?
Oh, I didn't push. Sorry, git push. So if I come here, we've got now the Travis CI pipeline, which is here. And if I just go to Travis now, if I remember where it is, account, sync account. Of course, I've got tons of. Maybe
I think it might be on the page.
Yeah, I've got too many. Yeah, where is it? Microservices here. So the search box didn't work. That's awesome. And so now I've got a Travis build for this. And if I can just trigger it.
Yeah, trigger.
It's a trigger build. Well, I will have a build with my no, not a custom build. Oh, what did it do? No, I'm going to force it. Git add git vi YOLO. It's just to add some stuff. Git push. That should trigger the build. Come on. Here it is. So it triggers the build, and we'll wait a little bit and we'll see the result.
So this one started?
Yeah, so now it started my, let's go back to my original demo. So here, we started our whole microservice architecture. So let's go to first thing, the JHipster registry. Is everything running? Remember me? So we've got a gateway, a microservice, and two microservices. Let's refresh this automatically. And we can go to the app. Oh, sorry. We can go to the application, which is here, sign in. And let's, I don't know, add again a beer. So I've got my architecture working. I've got the registry working. We talked about the JHipster console. Here it is. So this aggregates logs from everything. So this is the basic screen from Kibana. But we've got dashboards which are already created for us. Now we can see the instances. Okay, we've got the gateway to microservices and the registry. And we've got some cool dashboards. I like this one, but can change, of course. I'm going to auto-refresh it. And so this is done by default by JHipster, so I didn't have to do anything to have all my logs aggregated and have all my dashboards, so that's really good. And so now we're going to have fun with those microservices. Docker. I'm going to scale them. Docker compose, scale. So I'm going to scale, of course, the online shop. So it's the one which has a database and then distributed Hazelcast cache. So I'm going to scale it 3 times. So we already got 1 instance. We're going to have 3 instances. Let's do this. So if we go here to online shop, for the moment we got just 1, and it's going to launch the other ones. And we're going to see those instances appearing here, and then we're going to play and crash some of them to see what happens. In the meantime, let's just have a look at Travis. Oh, connection timed out. Yeah. So good, good advertisement for Travis. Now it's working. So Travis is done learning everything. I don't even know what it's doing because
it's running the tests and now packaging.
Building war. Yeah, build success. Should be happy. Oh, sorry. So, as you see, here also, I didn't code anything. I just used the correct subgenerator and everything is done for me. Well, I didn't even know the Travis syntax or anything. I just asked JHipster to build a Travis pipeline for me. So, it's starting up. Let's have a look at my instances. So it's so that there are 2 new instances arriving, starting. Something quite fun here. And let's go to Discover. Remember we were using Hazelcast. So there's a little request I love with Hazelcast. This one. As you can see, there's my main microservice application. So the 2 other services. So now I've got a cluster with 3 members. It already sees it, so I know that Hazelcast is working here. Because it saw it in the logs, it saw the IP of the others. You see, you've got the different IPs and everything, the instance names, and it sent it to the JHipster console, so I know everything is running fine. So now, if I go to my app here, so to the JHipster registry, I see everything is running. And if I go to my gateway, administration, gateway, as you can see, the online shop, now we've got 3 instances of the same microservice, which are all up, of course. And it is going to load balance a request between those microservices. So if I go to product again, so this is supposed to be load balanced. Of course, we're going to have to prove that. Well, it works like that, but we don't know if it, on which server it is running. So let's kill some stuff, basically. Going to schematic, so we have a graphical view of what I'm doing. So you see we've got 3 instances here, 1, 2, and 3. I'm going to kill the first one. And just to be sure, I'm going to kill also the second one. Did I kill the, which one did I kill?
Yeah, that was.
Sorry, I killed the second one. This one is the first one. So I killed the first 2 ones. So as we said, So the registry didn't see it yet. That's the issue with Eureka. It didn't time out yet, so it's blind. Oh, thinks everything is okay. And here, of course, as it's replicating here, it's also blind, so it thinks everything is okay, but it's not okay. So you go to a product. You can say it's failing. Let's create a product. Hello. It's failing. It's going to, normally, it should run Robin with the other instances. We're going to wait a little bit. Oh yeah, sorry. Just one thing with general, because this thing is really bad. Just a new error message which show. Something we didn't tell. We had a change in JHipster in the, let's say, last couple of months.
Almost 1 or 2 months. Yeah.
We added the Zalando JHipster Spring problem library. So it's a library to handle your Spring MVC REST issues using, I don't remember the number of the RFC, but there's a specific RFC for that. Yeah. So this is the one thing.
It's supposed to be standard error messages and stuff. So
if we have a look
for 500 errors, it's throwing general.
If we have a look at the error here, hopefully we'll get it. Yeah. So now we've got errors, in JSON. You've got an error page, so you should of course customize it. Got a title and so on. And if I go there, of course we did some basic error messages for you, and we tell you here how to customize the class, of course. So everything should be fine again. It's thinking, oh, that's still general. It will come back.
I think it is still not registered. Still not.
No, it should work. Hang on. Oh, it says.
Still has to.
Don't know what it's doing. We're in a bad state. So we have an issue here because it should run Robin with the remaining server. It's working quite bad. We'll wait a little bit. You will see in, let's say, a couple of minutes. It will come back. It always does. So it will do. And we will see, what we can have a look here also is, as you see, here in just JHipster console, we had 3 members, then just 2, then just 1. He saw me killing them, and he sent the information. And if I go to the dashboard, I see the other microservices.
I think it is.
No, there's already one which has disappeared and one which has not disappeared yet. It's taking some time. Anyway.
So this is much more faster with console compared to.
And now it saw it, and now it's working again.
Yeah. So now it has. Now it knows.
And now it's it's working.
Now I think in the registry, in the gateway, it shows.
Everything is good now.
Yeah.
So that's exactly the issue.
So it takes around 30 to 60 seconds normally for it to.
We do some optimization. I was hoping it was going to be better than that, honestly, but yeah. Anyway, whatever we do after, let's say, a few minutes, it's always come back and it's always work, and then you can scale again and so on, and we can have fun with it.
I think we only have 3 minutes left.
We have 3 minutes left, so let's move on. Going to production. It's very easy slide anyway, because we did that already quite a lot without telling it. With JHipster, we got a dev mode where everything is auto-loaded and so on. That was the biggest part of our talk last year.
Yeah, the developer experience.
In prod mode, we have a specific build. That's what we do all the time with Docker. So we use a specific Webpack configuration to greatly optimize the front end. There's a lot of work from Deepu, from lots of people, but especially Deepu, on the Webpack configuration. Spring Boot has got a specific configuration with no auto-loading, with bigger cache values and so on. By default, our caching values are quite low because you can monitor all of them. That's what you can see in the registry here, metrics. You can see. Oh, sorry, not this one. Let's go to my application. Here, you're going to see all your endpoints, performance, your caches, and you're going to be able also to see them here. We've got a specific dashboard for that. We've got only for OH cache. Oh yes, good. Yeah, and I'm not using OH cache here. Yeah, because it doesn't work the same way for the others. But basically, we've got tons of monitoring for you, so you can see if your cache is good or not. And of course, by default, it's a bit low, and it's up to you to increase it. The final result that we generate with that production build is an executable WAR file. Usually people tell it an executable jar file. We keep the WAR suffix because you can also deploy it to Tomcat or into an app server, and for that you need to have the WAR suffix, the WAR extension. But it's a jar file, it's an executable jar file. It has got an embedded undertow server, so undertow is an app server from JBoss, which is very light. And it can be run directly like this. It's just an executable file, in fact. I didn't do it here because I wanted to have my SQL, I wanted to have the JHipster Registry, and so on. But if I want to run everything in a simple way, it's just an executable WAR file. That's also why we support a lot of cloud. We support OpenShift, Cloud Foundry, Kubernetes, Heroku, lots of them, Rancher. We support tons of them because basically it's just an executable file. So all of them support Java and can run an executable file, so it's quite easy to run anywhere. From that executable WAR file, you can also do what I just did several times before. You can build a Docker image, which is based on Alpine with the Java 8, GRE only. As it's a Docker image, you're supposed to be able to run it easily everywhere, except like in my little example when Docker crashes. But that's not supposed to happen. And we've got 30 minutes left, so do you have any final words? Oh, yes, you've got some final words.
It's supposed to be QA. I have a discount code for books here if somebody is interested. So we'll post the link. Well,
just tweet it, and we'll tweet it with the JHipster account.
This thing as well. So if somebody is interested, you can grab a copy. It's supposed to be coming out next year, beginning of next year. Of course, Q&A.
Yeah,
don't have much time,
I think it's time up, but you can just come, and we have lots of time. And we will be there for the whole week. Well, I won't be there tomorrow and the day after, but Deepu's here, and I will be there on Thursday and Friday, so just come and have a talk if you want to.
We also have a BOF on Thursday.
Oh, yes, there's a bird of a feather on Thursday evening.
Yeah,
there will be match variables, there will be lots of things. So bird of a feather is like the community together in the evening.
We can also have a lot of Q&A then as well.
Oh, yes. Well, that's
there'll be Julien, me, Matt Rabel, and Sendil from the core team.
So we've got the 4 main contributors, basically. Yeah. So, yes, if you have questions, don't hesitate to come to the BOF session on Thursday evening. It's the best place. We will have T-shirts.
Yes, we have special JHipster T-shirts as well.
Yes, so if you want to collect our T-shirts, that's the place to go. Thank you. Thanks a lot.
Thank you.